Hey, champs of Examsnet. Welcome to the question series of Examsnet. Today we'll be solving TS EAMCET 18 July 2022 Shift 1 paper. So I hope you're already well prepared for your exams, and these exams are going to be a bit tough one. In this paper, we'll be having 80 mathematical questions. This video is going to be on the 80 mathematical questions for this paper. Hope you are well prepared. Best of luck. Here we start. Before that, please visit our website www.examsnet.com. There you will find this type of many more entrance exam question papers for your practice. You can also download our app. The link is available in the description box. So let's start with the paper. Here we go. First question. The domain of the real valued function fx is equal to this is. So domain refers to the all the possible values of x which make this whole LHS the RHS a valid one. So for that, first thing they are said real valued function. So if that is a real valued function, then 6x square plus 5x minus 6 should be greater than 0, equal to 0, right? It should not be negative, because if it is negative, it would have become imaginary. So first thing is this is greater than equal to 0. So let's split the middle term. You will have 6x square plus 9x minus 4x plus minus 6 greater than 0. Let's take 3x common. 2x plus 3 minus 2x plus 3 should be greater than equal to 0. So here I have the factors 3x minus 2 and 2x plus 3 should be greater than equal to 0. From where I get x is, see, both of them, they should be either greater than 0 or less than 0, right? That means if I have this 3x, x will be equal to 2 by 3. And from here, I'll have x is equal to minus 3 by 2, right? Both should be negative or both should be positive. And according to that, the x should belong to minus infinity, right? Because it can go on this side to minus 3 by 2 union 2 by 3 to infinity, right? Okay, now second thing, the denominators should not be equal to 0. First thing, 4 minus x should be greater than equal to 0. See, these are in the under root, right? So they should be greater than equal to 0. That means x should be greater than equal to minus 4. Also, second thing, x plus 4. Sorry, here is plus 4. X plus 4 should be greater than equal to 0, which means x should be greater than equal to minus 4. So from here, if I take this one as number 1, 2, 3. So let's make the intersection of, see, from here, x will belong to minus infinity to 4. And from here, x will belong to minus 4, closed interval. Here is a closed interval, infinity. Okay. So let's do the intersection of 1, 2, and 3. We will get x belongs to minus 4 minus 3 by 2 union 2 by 3 and 4 intersection. So with that, let's check with the options what we have. We have option A as the correct answer. Hope you understood this. Next is question number 2. Okay, it says if x represents a greatest integer which is less than equal to x, then the range of the real valued function this is. Now let's write now. Fx is given to you as 1 upon root of greatest integer function square plus this minus 2. This can be written as 1 upon, I want to make a perfect square out of it, so I can write it like root of x plus, wait, this will be x plus 1 by 2 whole square minus 9 by 4. If you will solve, if you want to make this one the perfect square, this can be written in this form, right? Now, the maximum value of this whole thing is infinity. So, if this is infinity, so if this thing is infinity, so fx is equal to 1 upon root of infinity minus 9 by 4. So root of infinity minus 9 by 4 will approach to 0. Correct? That means, one more thing, to make this thing positive, because it is in the root and we want a real valued function. So to make greatest integer function x plus half square minus 9 by 4, if this is the minimum one, to be positive, this should be equal to 2, because a value less than 1 will make this whole thing to be negative, and I want it to be positive because it is under the root. So 2 plus 1 by 2 whole square minus 9 by 4 will make it 25 by 4 minus 9 by 4, which will be equal to 16 by 4, which is equal to 4. So fx will be equal to 1 by root of 4, which is equal to 1 by 2. So that means the range will be open, closed. So this is the answer to the question. Let's check. We have option B as the answer. Hope you understood this. Next is question number 3. Okay, we have a matrix problem now. So let A is this, B is this. If trace of A is minus 4 and AB is equal to this, then A plus B plus C plus D is equal to what? So first thing, you are given the trace of A is minus 4. And what is the trace of A? It's given by my A plus minus 1 plus minus 4. This is equal to minus 4. So you will have A is equal to 1. This is what you got. Next thing, you are given that, okay, fine. Now I can write down 1 in the place of this A. First is you got A matrix as 1, 3, 5. 5 minus 1, 3. Then 2, 3. Let's make it a bigger one. So 2, 3, and minus 4. B is B1, 4. 4C1 minus 3, 1, D. So the product of the two is equal to AB is given by this. Let's find out the product first of all, AB. So A multiply B will give you, first column, this will be B plus 12 minus 15. Next is 1 plus 3C plus 5. Then you have 4 plus 3 plus 5D. Then 5B minus 4 minus 9. Then you have 5 minus C minus 3. Then you have 20 minus 1 plus 3D. Last row, first column, 2B plus 12 plus 12. Then you have 2 plus 3C minus 4. Then you have 8 plus 3 minus 4D. So let's solve it now. You will get AB is equal to B minus 3, 3C plus 6, 5D plus 7, 5B minus 13, C, wait, this is, wait. So here is 5, second row. So 5 minus C and plus 3 here was. So this will be 8 minus C. Okay. Next is 3D plus 19. Next will be 2B plus 24. 3C minus 2. 11 minus 4D. So this is AB. Now this is given to you in the question. It's given AB, the product of the two, is equal to minus 1, 0, 17, minus 3, 10, 25, and 28, minus 8, and 3. Okay. So now let's equate them. From here, you will get B minus 3 is equal to minus 1, which will give minus 1, which will be B is equal to 2. A we already got as 1. B is 2. Let's go for C. So 3C is equal, 3C plus 6 is equal to 0, which gives you C is equal to minus 2. Let's go for D. 5D plus 7 is equal to 17, which gives you 7, sorry. 5D plus 7 is equal to 17, which gives you 10 divided by 5, which will give you 2. That means A is equal to 1, B is equal to 2, C minus 2, and D is 2. You have to find out A plus B plus C plus D. That means 1 plus 2 minus 2 plus 2, which will be equal to 3. So we have option C as the correct answer. Hope you understood this. Next is question number 4. Okay, now you have to find out the determinant of it. This is a matrix and you have to find out the determinant. Easy one. Here is a 1 identity matrix. One row is having all the ones. So this will be 1 outside B square C cube minus B cube C square minus 1. A square C cube minus A cube B square plus 1. A square B cube minus A cube B square. Let's open it now. So you will get, I'll pick up the first over here. This will be A square B cube minus A square C cube. This one. So I'll put it in the brackets, both the A square ones. Now next, B square C cube minus A cube B square plus A cube C square minus B cube C square. I'll take the A square common from here. You will have A square B cube minus C cube. Similarly, I'll take B square common from here. I'll have C cube minus A cube. And now I'll take C square common from here. I will get inside A cube minus B cube. So this resembles with the, yes, option B, right? So we have option B as the answer to this question. Hope you understood. Next is question number 5. Let alpha and beta be the real numbers and A is given by this matrix is a 3 by 3 matrix, which is satisfying that A multiplied by this is equal to this. Then you have to find out adjoint of A inverse plus adjoint of A inverse is equal to what? All right. So you are given that alpha and beta and gamma are the 3 real numbers. You are given A is equal to, A matrix is 7, 3, alpha, beta, 1, minus 11, minus 5, gamma, and 11. Now you are given that this multiplied by 5 minus 13, 11 gives you 290 minus 119 and 210. Okay, let's go for it. Let's do the multiplication. So you will have 7 multiply 5. This is 35 minus 39 plus 11 alpha. Then 5 beta minus 13 minus 121 minus 25 minus 13 gamma plus 99 is equal to minus 290 minus 119 and 210. Right? Now just you have to equate them. First of all, okay. You will say this is minus 11 alpha minus 4 is equal to minus 290, which gives you alpha will be equal to 290 plus minus 290 plus 4 upon 11. This will give you minus 26. Let's go for beta. You have 5 beta minus 134 is equal to minus 119, which gives you beta is equal to minus 119 plus 134 whole divided by 5, which will give you beta is equal to 3. Let's go for gamma. Minus 13 gamma, then 9. Okay, this is 99 and 25. Wait, there is a mistake. Here was 19 instead of this, and you will have 209 over here. This is 209, and here you will have minus 13 gamma plus 184 is equal to 210. Minus 13 gamma will be 210 minus 84, which is equal to probably 26, or gamma will be equal to minus 2. So now let's make the A matrix. A matrix came out to be 7, 3, minus 26, 3, 1, minus 11, and minus 5, minus 2, 19. This is the matrix A. Now let's find the adjoint of it. First of all, we'll find the determinant. So this will be equal to 7 minus 3 minus 3, 2 minus 26 minus 1. Question number 5, let alpha, beta, gamma be the real numbers. If A is given to be this matrix and this is a 3 by 3 matrix satisfying this particular equation, then adjoint of A inverse plus adjoint of A inverse is equal to. So you are given A is equal to this 7, 3, alpha, beta, 1 minus 11 minus 5, gamma, and 19. And this multiplied by 5 minus 13, 11 gives you this matrix. Let's multiply both of them first. So you will get 7. This will be given by 7 multiply 5 plus 3 multiply minus 13 plus 11 multiply alpha is equal to, not is equal to, the next line will contain, row will contain 5 beta minus 13 minus 121 minus 25 minus 13 gamma, and 19 multiply 11 will give you 209. This is equal to minus 290 minus 111 and 210. Let's go. So you will have 35 minus 39 plus 11 alpha, 5 beta minus 134 and minus 13 gamma plus 184. This is equal to minus 290 minus 119 and 210. So this 11 alpha minus 4 is equal to minus 290. Then 5 beta minus 134 minus 119 and minus 13 gamma plus 184 is equal to 210. So 11 alpha is equal to minus 286, which will give you alpha is equal to minus 26. Here the beta will come to be 3 and gamma will be equal to minus 2. Right? Now we got the values for alpha, beta, gamma. Let's fill that in A. Now the A matrix will become 7, 3, minus 26, 3, 1, minus 11, minus 5, minus 2, and 19. Let's find out the determinant. Determinant will be given by 7, 19, minus 22, minus 3. This will be 57, minus 55. Then minus 26, minus 6, plus 5, which is equal to 7 into minus 3 into 2, minus 26 into minus 1. That is minus 21, minus 6, plus 26, which is equal to, this will be equal to minus 26 minus 1. Okay. So determinant of A came out to be minus 1. What we were asked in the question was adjoint of A inverse and adjoint A inverse. Okay. Now you know one thing, A inverse is equal to adjoint A upon determinant of A. From here, adjoint A is equal to A inverse into determinant of A, right? You can also say, now in the question we were asked, adjoint of A inverse plus adjoint of A inverse. This is equal to adjoint of A inverse plus adjoint of A inverse, which is 2 adjoint of A inverse. So here, this is equal to, we got, this is equal to A inverse into A, determinant of A it was. Right? So this can be written as 2A into inverse of A, which is equal to 2A upon determinant. See, this is determinant. Determinant of A, which is equal to, determinant of A was minus 1. So this is equal to minus 2 of A. So we have option D as the correct answer. Hope you understood this. Let's move to the next question number 6. If alpha, beta, gamma multiplied by this matrix is equal to this matrix, then alpha cube plus beta cube plus gamma cube is equal to what? So you are, suppose let this be matrix A. So this is equal to 1, 2, 3, 2, 3, minus 5 and 1, 2, 5. Now this is matrix A. You are given in the question alpha, beta, gamma is equal to 3, 5, 2 into matrix A. Or you can say alpha, beta, gamma is equal to matrix alpha, beta, gamma is equal to A inverse into matrix 3, 5, and 2. Now, A inverse can be written as adjoint of A upon determinant of A. Let's find out these two things, adjoint of A and determinant of A. First of all, go for adjoint of A, determinant of A, sorry. So, A matrix was 1, 2, 3, 2, 3, minus 5 and 1, 2, 5. Let's find out the determinant. This will be 1 into 15 plus 10 minus 2, 10 plus 5 minus 3 is equal to plus 3 multiplied by 4 minus 3, which is 25 minus 30 plus 3. That is equal to minus 2. This is determinant of A. Now let's find out adjoint of A. So for finding adjoint of A, there's a long procedure. Actually, you have to find out the cofactors first of all. So let's find out the cofactors. A11 will be given by 3 minus 5 and 2, 5, which is equal to 15 plus 10, that is 25. Next, A12, first row, leaving first row, second column, you will have a 2 minus 5, 1 and 5, which will be 10 plus 5, 15. First row, third column, 2, 3, 1, 2. This will be equal to 4 minus 3, that is equal to 1. A31, third row, first column. Third row, first column I'm leaving. So you will have, sorry, not 3, 1. I'll go for 2, 1 first. Second row, first column. So you'll have 2, 3, 2, 5. That will give you 4. Second row, second column. 1, 3, 1, 5. which will give you 3 minus 5, that is minus 2. Sorry, 5 minus 3, which will give you 2. Next, second row, third column, 1, 2, 1, 2, 0. Third row, first column, 1, 2, 2, 3. 3 minus this, minus 1. Third row, second column. Third row, second column, 1, 3, 2, minus 5. Minus 5, minus 6, minus 11. The last one, 3, 3. Third row, third column, you will have 1, 2, 2, 3. Third row, third column. Give me a minute. I think this I have done wrong. This is third row, first column, right? So this is 2, 3, and 3 minus 5. Okay. This is, I have to go for third row, first column. I'll solve it again. So 2, 3, 3 minus 5. This will be minus 10, minus 9. That is minus 19. Okay. So now this is equal to 3 minus 4, which is equal to minus 1. Now let's find out the cofactors. Write down the cofactors of A. This will be equal to 25 minus 15. See, why minus 15 over here? Because this is second row, first column. This is actually written as minus 1 raised to power 1 plus 2, which is equal to minus 15. Here is 2, 1. Minus 1 raised to power 1 plus 2. This is equal to minus 4. Right? Here is minus 1 raised to power 1 plus 3. This is equal to minus 1 raised to power 4, which is positive only. Here also minus 1 raised to power 1 plus 1. This is positive. Similarly, this is positive, this is negative, 0, negative. As such, I'll write down 3, 1, minus 19, 3, 2. This will be plus 11. 3, 3 is minus 1. That's it. Okay, let's write down the cofactors. So 1, 3, this is 1. Then here is second row, first column, minus 4, 2, 0. Then you have minus 19, 11, and minus 1. So now let's write down the matrix adjoint of A. This is given as 12 minus 15, 1, minus 4, 2, 0, minus 19, 11, and minus 1. This is adjoint of A. So now let's get back. We were over here. We were at this section. Okay. So now come back to this one. Let's now take this as number 1. From number 1. From 1, alpha, beta, and gamma is equal to adjoint of A came out to be 25 minus 4 minus 19 minus 15 to 11, 1, 0, and minus 1. Whole divided by adjoint of A, which was minus 2. So this is minus 1 by 2. And it was supposed to be multiplied with 3, 5, and 2 matrix. Done. Now let's go for the multiplication. So alpha, beta, gamma is equal to minus 1 by 2. 25 multiplied 3, 75 minus 20 plus minus 38. Then minus 45 plus 10 plus 22. 3 plus 0 minus 2. Okay, this is minus 1 by 2 into 75 minus 20 minus this. This is equal to minus 58. So 75 and 58, the difference between the two is This is 17. Okay. Question number 6. If alpha, beta, gamma multiplied by this matrix is equal to this, then alpha cube plus beta cube plus gamma cube is equal to what? So first of all, let's assume this one is matrix A. A matrix is 1, 2, 3, 2, 3, minus 5, 1, 2, and 5. This is matrix A. And you are given that this alpha, beta, gamma multiplied by matrix A is 3, 5, and 2. So you can also say alpha into beta, sorry, not alpha, beta, gamma is equal to A inverse 3, 5, 2. Now A inverse can be written as, actually this is over here, A inverse, not this side. So 3, 5, 2 into A inverse is given by adjoint of A divided by determinant of A. Now we have to find out these two things. Let's go for determinant of A. A matrix is equal to 1, 2, 3, 2, 3, minus 5, and 1, 2, 5. Looking at that, A determinant is 1 multiplied 15 plus 10 minus 2, 10 plus 5 plus 3, 4 minus 3, which will give you 25 minus 30 plus 3. That is equal to minus 2. So determinant of A came out to be minus 2. Now let's go for finding out adjoint of A. For that, first of all, we need to find the cofactors of A. So let's find out cofactors. A11 is given by 3 minus 5, 2, 5, which will give you minus 1 raised to power 1 plus 1 multiplied 15 plus 10, which is 25. First row, second column, this is given by 2, 5, 2 minus 5 and 1, 5, which is minus 1 raised to power 1 plus 2 multiplied by 15, 10 plus 5, which is equal to minus 15. Next, first row, third column, this is equal to 2, 3, 1, 2. This is equal to minus 1 raised to power 1 plus 3 multiplied by 4 minus 3, which is equal to 1. Then first row, sorry, second row, first column, this is written as, let's see, this is written as first row, second column. So second row, first column, 2, 3, 2, 5. 2, 3, 2, 5. That is minus 1 raised to power 2 plus 1. 10 minus 6, which is equal to 4. Minus 4 actually. Next, second row, second column. This is 1, 2, 1, 2. Minus 1 raised to power 2 plus 2, 2 minus 2, which is equal to 0. Second row, third column. This is equal to, second row, third column is given by, actually this is second row, third column. 1, 2, 1, 2, which was equal to minus 1 raised to power 2 plus 3, 2 minus 2, 0. Second row, second column was 1, 3, 1, 5, which is equal to minus 1 raised to power 2 plus 2, 5 minus 3, which is equal to 2. Okay. Now let's go for the third row, first column. This is 2, 3, 3 minus 5. Minus 1 raised to power 3 plus 1. This is minus 10 minus 9, which is equal to minus 19. Now, third row, second column. This is 1, 3, 2 minus 5. Minus 1 raised to power 3 plus 2 minus 5 minus 6, which is equal to 11. Plus 11. Next, third row, third column. 1, 2, 2, 3. minus 1 raised to power 3 plus 3. 3 minus 4, which is equal to minus 1. So you got all the cofactors. Let's write down cofactors of A. Those are 25 minus 15, 1, minus 4, 2, 0, minus 19, 11, and minus 1. Adjoint of A is written as 25 minus 15, 1, minus 4, 2, 0, minus 19, 11, and minus 1. These are the cofactors. Sorry, this is the adjoint, and we have the adjoint and we have the determinant, which we calculated here. Now let's fill in equation 1. We had over here matrix alpha, beta, gamma is equal to 3, 5, 2 multiplied by adjoint of A. Adjoint of A was 25 minus 4 minus 19 minus 15, 2, and 11, 1, 0, minus 1. Okay, and this is divided by minus 2, so this can be written as minus 1 by 2 over here. Now let's solve it further. You will do the multiplication of the matrices. Minus 1 by 2. So this is 75 minus 75 plus 2 minus 12 plus 10 plus 0 minus 57 plus 55 minus 2. This will give you here minus 1 by 2 into 2 minus 2, and I will have minus 4 over here. So this is equal to minus 1, 1, and 2. Alpha, beta, and gamma. So from here, alpha is equal to minus 1, beta 1, and gamma 2. Alpha cube, beta cube, gamma cube is minus 1 cube plus this, which is equal to minus 1 plus 1 plus 8. That is equal to 8. So we have option A as the answer to this question. Hope you understood this. Let's move to the next question, number 7. So root of, this is a complex number problem, root of minus 3 plus 4 iota multiplies 8 plus 6 iota is equal to what? So to solve the question, first of all, let's simplify it. Root of minus 3 plus 4 iota, 8 plus 6 iota. This is equal to minus 3 this, minus 24, minus 18 iota, plus 32 iota, minus 24, which is minus 48 plus 14 iota, which can be written as, I'll take 4 common from here. So this can be written as root 2 multiply, I'll take 2 common from here actually, minus 24 plus 7 iota. Now we know one thing. We know that real part of this is equal to root of modulus of z plus real part of z upon 2 plus iota z modulus minus this upon 2 for imaginary part to be greater than 0. So this can be written as, therefore, minus 24 plus 7 iota is equal to plus minus root of 25 minus 24 upon 2 plus iota 25 plus 24 upon 2 plus minus, this is equal to 1 by 2 root plus iota 49 by 2, which is equal to 7 upon root 2. I'll take root 2 common. So I'll have 1 plus 7 iota over here. Now, therefore, this thing minus 3 plus 4 iota, 8 plus 6 iota is actually equal to plus minus 1 plus 7 iota. Right. So let's see. We have option C as the answer. Hope you understood this. Let's move to the next question then. Question number 7. This is a complex number problem. The two complex numbers are being multiplied and they are under the root. Let's multiply them. So you will have, this will be root of minus 3 into 8. This is minus 24 minus 18 iota plus 32 iota and 24 iota square, which is actually equal to minus 24, right? This is equal to 24 iota square is equal to minus 24. You know this thing, iota square is equal to minus 1. Okay, so this will be minus 24 and this is minus 24. Minus 24 into minus 24 minus 24 will give you minus 48 plus 14 iota. Now let's take common from it, root 2. You will have root of minus 24 plus 7 iota, right? So now we see, if I have to find out the roots of it, the root of z is given by plus minus whole root of modulus of z plus real part of the complex number, this is z, upon 2 plus iota, same thing, modulus of z here is minus real part of the complex number divided by 2. So, okay, we need modulus of z for this also. Let's calculate modulus of z. I hope you already know how to calculate the modulus. So the modulus can be calculated by root of minus 24 square plus 7 square. Minus 24 is equal to, this is equal to 500 something, just a minute. So 96, 24, sorry, this is 96 and 48, 576 plus 49. This is 625, which is 25. So modulus of z is equal to 25. Let's write it. This is 25 root of plus minus outside plus real part was equal to minus 24 whole divided by 2 plus iota root of 25 minus of minus 24 upon 2. So this is hold the thing under the brackets. Let's hold it further. You have 25 minus 24. This is 1 by 2, root of 1 by 2 plus minus outside plus iota. This is 49 by 2. So root 2, let's take it common from both of them. You will have 1 plus 49 root 7, so 7 iota. These are the roots of this complex number, root of under root of z. So now this is what we needed, and the given expression was minus 3 plus 4 iota, 8 plus 6 iota. This is equal to plus minus 1 plus 7 iota. Okay, this is a constant. And so what we have option C as the correct answer to this question. Hope you understood. Next is question number 8. Again, a complex number problem. Okay, if root of 3 plus iota upon root of 3 minus iota whole raised to power m is equal to 1, and m lies between 2022 and 2029, then m is equal to, we know one thing, that omega can be written as minus 1 by 2 plus root 3 by 2 iota, and omega square can be written as minus 1 by 2 minus root 3 by 2 iota. Let's take it to omega is equal to minus 1 plus root 3 iota, 2 omega square is equal to minus 1 minus root 3 iota. Now let's multiply both the sides with iota. You will have 2 omega iota is equal to minus iota. Omega square is minus, so this is minus root 3. And you will have 2 omega square iota is equal to minus iota plus root 3. Correct? Now what we had to find out, okay, let's take minus common from here. So you will have minus 2 omega iota is equal to iota plus root 3, and let's take minus 2 omega square iota is equal to root 3 minus iota. Now let's see, we got what we wanted in the brackets, right? So on root 3 plus this is raised to power n, this can be written as minus 2 omega iota upon minus 2 omega square iota. 2, this will cancel, iota will cancel, and you will be left with omega raised to power m. Okay, now this is given to be equal to 1. You know one thing, that omega cube is equal to 1. So that means, first of all, this m is a multiple of 3, right? That is the only possible case. Then you will have 1 in the RHS. So this m should be a multiple of 3. Sorry, this is 1 upon omega. Okay, so this can be written as omega raised to power minus 1 whole raised to power m. Same thing, m will be a multiple of 3 in any case. So what is the number 2002 and 2029, which is a multiple of 3? Let's see, this is 2025. This is a multiple of 3, and 2028, which is a multiple of 3. 2025 is not in the list. We have 2028. So we have option C as the answer to the question. Hope you understood this. Let's move to the next question. Question number 9. It says if 1 omega square are cube roots of unity, then if n belongs to the natural numbers and greater than 2, n is greater than 2, then the least value of n such that 1 plus omega is a root of this number, this equation is. So first thing, if it is saying 1 plus omega is the root of this equation, then we can write down 1 plus omega whole raised to power n minus 1 plus omega is equal to 0, which gives you 1 plus omega raised to power n is equal to 1 plus omega, which will give you 1 plus omega raised to power n minus 1 is equal to 1, right? This will go in the denominator, 1 plus omega, and see, the bases are same, powers will be subtracted. So I'll have 1 plus omega raised to power n minus 1 is equal to 1. You know one thing, 1 plus omega square is equal to 0. That means 1 plus omega is equal to minus omega square. So this can be written as minus omega square raised to power n minus 1 is equal to 1. Now n belongs to natural numbers and is greater than 2. Okay. If I'll take n greater than 2, let's take n is equal to 3. If I'm taking n is 3, so minus omega square and 3 minus this 2, which will be minus omega raised to power 4. Sorry, not minus, minus will go away. So omega raised to power 4, you know, this is equal to omega in 1 into omega, or simply omega. So this is not true for n is equal to 3. Let's try for n is equal to 4. So this will be minus omega square, 4 minus 1, that is 3. Okay, so this can be written as minus omega cube whole raised to power 2 minus 1 raised to power 2, which is equal to 1, which is true. So this comes out to be true for n is equal to 4. Similarly, if I will try for n is equal to 7, this will be minus omega square raised to power 6, which can be written as minus omega raised to power 6 square, or minus 1 square, or this is equal to 1 again. So that means it will go on, like n is equal to 4, it will be valid, n is equal to 7, it will be valid, 10 is equal to valid, and so on. Okay. So what we needed the least value of n. So the least value of n is equal to 4, for which it is true. That means option D stands to be the correct answer to the problem. Hope you understood this. Next is question number 10. It says if x belongs to complex numbers, and actually the question is here is x belongs to real numbers over here also. And there is such that this equation is belonging to real numbers. And this is for set A and this is for set B. There is x which belongs to real numbers and this is true. Then A intersection B is. First of all, A is x belongs to the real numbers such that root of x squared minus 8x plus 15 belongs to real numbers, right? If this belongs to real numbers, then that means the root, which is x squared minus 8x plus 15, it should be greater than equal to 0 because it is under the root. Let's factorize this. You will have x squared minus, the two factors will be 5x and 3x plus 15 is greater than equal to 0, or x minus 5 and x minus 3 will be the two roots. Got it? So that means x will belong to open minus infinity 3 union 5 and infinity, which is actually A. So A set belongs to minus infinity 3 union 5 infinity. Now let's go at B. B was x belongs to real numbers such that x minus 3 upon 2x minus 5 is less than x minus 6 upon 2x minus 11. Now let's pick it up. X minus 3 upon 2x minus 5 is less than x minus 6 upon 2x minus 11. I'll take it on the left hand side. So you will have x minus 3 upon 2x minus 5 minus x minus 6 upon 2x minus 11 is less than 0. Now let's take the LCM. So you will have 2x minus 5, 2x minus 11, which will give you x minus 3 into 2x minus 11 minus x minus 6, 2x minus 5 is less than 0. So let's do the cutting and everything. Let's open it up. You will have 2x square minus 11x minus 6x plus 33 minus 2x square minus 5x minus 12x plus 30 whole divided by 2x minus 5 and 2x minus 11. This is less than 0. So this will cancel. This is 17. This was supposed to be plus, sorry. This was plus and this was supposed to be minus because I opened the brackets and minus was outside. Okay, so this is minus 17 and this is positive 17. They will also eventually cancel out and you will be left with 3 upon 2x minus 5, 2x minus 11 is less than 0. Correct? Okay. So that means what the interval of x will belong to. See, these two numbers, if I'll take, I'll put 2x minus 5 is equal to 0, x will be equal to 5 by 2. And 2x minus 11 is equal to 0, x will be equal to 11 by 2. So these are actually the two factors, right? 2x minus 5 and 2x minus 11 for the denominator. From here, x will belong to over here 3 or you can write down x will belong to minus infinity 5 by 2 union 11 by 2 infinity, right? Now this is actually B. B is also equal to the same. What you had to find out? We had to find out A intersection B. So A was equal to minus infinity 3 union 5 infinity. Right? So let's do the union of both of them. Sorry, intersection of both of them. Intersection of both of them will give you 5 by 2, comma 3 union 5, 11 by 2 open. Okay. So this is the answer to the question. Let's check with the options. What we have. Yes, we have this one, option B. This is the answer to our question. Hope you understood this. Let's move to the next question, number 11. If the extreme value of 3x minus 2x squared plus 1 is equal to k, then the set of real numbers of x for which this is greater than 0 is. First thing, you are given extreme value for the function. So let the function be fx 3x minus 2x squared plus 1. Extreme value, we have to find out the derivative. So for extreme value, the derivative is equal to 0. Correct? So let's find out the derivative. F of x, this is equal to 3 minus 4x plus 0. So 3 minus 4x is equal to 0. Yeah, for the extreme value, or x will be equal to 3 by 4. This will be the value of x. Now, then the set of real values of x for which this is greater than 0. So let's write it down. It was kx squared plus 2x plus 1 is greater than 0, which will, I had the value of k as, see, the extreme value of this function is k. So that means this is equal to k. That means 3 by 4 x squared plus 2x plus 1 is greater than 0, which will give you 3x squared plus 8x plus 4 is greater than 0. From here, let's factorize this one. So you will have the two factors 12 and 8. It will be 6 and 2. 3x squared plus 6x plus 2x plus 4 is greater than 0. 3x x plus 2 x plus 2 is greater than 0. So from here, the two factors will be x, 3x plus 2 and x plus 2 is equal to 0. Or you can write down x plus 2 by 3 into x plus 2 is greater than 0. From here, x will belong to minus infinity, minus 2 by 3, union, minus 2 and infinity. So this is the value. Let's check with the options. Then the value, then the set of all real numbers of x for which this is greater than 0 is not this, not the second one as well. No. So the answer is none of the above. So option E is the correct answer to this question. Hope you understood this. Let's move to the next question. It says if alpha, beta, gamma are roots of this cubic polynomial equation, then this whole expression is equal to. So it's x cube minus 5x square minus 2x plus 24 is equal to 0. Alpha, beta, gamma are the roots of the equation. So see, one thing we have, sum of roots. This is minus b upon a. See, if it is of the form ax cube plus bx square plus cx plus d is equal to 0. Sum of the roots is given by b upon a. Sum of product of the roots is alpha, beta, beta, gamma, and alpha, gamma, which is equal to c upon a. Also, product of the roots, only product of the three roots. This is equal to minus d upon a. So remember these formulas, don't forget them. We'll be using here. Alpha plus beta plus gamma. This is equal to minus b upon a, which is minus of minus 5 upon 1. That is equal to 5. Alpha, beta, beta, gamma, and alpha into gamma is minus 2 upon 1, which is equal to minus 2. Alpha, beta, gamma is equal to minus 24 upon 1, which is minus 24. Okay, right? So we have these three values. Now what we had to find out? This. Let's pick it up. It is from question. Beta, gamma upon alpha upon beta upon gamma. So let's take the LCM. You will have alpha, beta, gamma is equal to beta square, alpha square, sorry, gamma square, alpha square, this square. Okay. Now this is C square, something x square plus y square plus z square. The square of the three terms. This can be written as And this can be written as, see, this was equal to minus 24. So minus 1 by 24, I'll take it outside. And you will have alpha beta, beta gamma, gamma alpha whole square minus 2 alpha beta square gamma, alpha beta gamma square, alpha square beta and gamma whole thing. So this is equal to minus 1 by 24. You know, this was equal to minus 2. So minus 2 square minus 2 alpha beta gamma. Let's take it common. And you will have beta plus gamma plus alpha. I hope you're getting this, right? So this is minus 1 by 24. 4 minus 2. This was equal to minus 24. And this was equal to alpha plus beta plus gamma was equal to 5. Okay, minus 1 by 24. This is 4 plus, this is 240, which is minus 244 upon 24. I think, yeah. Okay, so let's do this, solve this further. So this is 61 upon 6, which will be minus 61 upon 6. So let's check with the options. I have option D as the correct answer. Hope you understood this. Let's move to the next question. Question number 13. If alpha, beta, gamma are the roots of this cubic polynomial or a cubic equation, then alpha, beta, gamma are in such that alpha, beta, gamma are in geometric progression and alpha is less than beta is less than gamma, then 3 alpha plus 2 beta plus gamma is equal to. So basically in the question, you have to find out the 3 values so that you can evaluate this given expression. Okay, let's write down the expression. It is 3x cube minus 26x square 52x minus 24 is equal to 0. So now you are given alpha plus beta plus gamma. This is equal to, this is equal to minus b upon a. So minus of minus 26 upon 3, which is equal to 26 upon 3. Next, alpha beta, beta gamma, and alpha gamma. This is equal to 52 upon 3. That is equal to, yeah, it will not be solved. Next is alpha beta gamma is equal to minus 24 upon 3, which is equal to minus 8. Minus of minus 24, so this will be plus 8. Okay, I hope you got these 3 things. Next thing, it is told that alpha, beta, gamma, they are in GP. So if they are in GP, that means beta square is equal to alpha into gamma. They are in the geometric progression. So this is there. So, okay, let's multiply both sides with the beta. So you will have beta cube is equal to alpha, beta, gamma. So that means this thing came out to be beta cube is equal to 8, which gives you beta is equal to 2. We got one value, beta is equal to 2. Now let's fill in this equation. So you have alpha plus beta plus gamma is equal to minus 26 upon 3. Beta came out to be 2. So alpha plus gamma is equal to 26 upon minus 26 upon 3 minus 2, which is minus 26. Give me a minute. Yeah. So you will have this minus 20. Sorry, this is plus 26 upon 3, right? So this is positive and this is minus 6 upon 3. So you will have it 20 upon 3. This is alpha plus gamma. Also, alpha into gamma. This was equal to beta square. Beta is 2. So alpha into gamma is equal to 2 square, which is equal to 4. Alpha into gamma is 4 and alpha plus gamma is equal to 20 upon 3. Okay. Now, let's get back to the equation. This one, we have these two equations. So from here, I can write down alpha is equal to 4 upon gamma. I'll fill this in this equation, which said alpha plus gamma is equal to 20 by 3. So alpha plus gamma is equal to 20 by 3. Alpha plus 4 upon alpha is equal to 4 upon gamma. Okay, let's write it down. You can say alpha plus 4 upon alpha. This can also be written this way. I have written something now. So gamma is equal to 4 upon alpha. This is equal to 20 upon 3. Okay. So from here, you will have alpha square plus 4 is equal to 20 alpha upon 3, or 3 alpha square minus 20 alpha plus 4 is equal to 0. 12, sorry, this is multiplied, right? So yeah, this will be 12. Now, I want two such numbers. The product should be 36 and the sum should be minus 20. And those two numbers, let's see, 3 alpha square and minus 18 alpha minus 2 alpha plus 12 is equal to 0. I'll take 3 alpha common. So alpha plus 6 and 2 common, alpha plus alpha minus 6 was and alpha minus 6 over here. So the two root factors will be 3 alpha minus 2 and the second one will be alpha minus 6 is equal to 0. From here, I'll have alpha is equal to either 2 by 3 or 6. These are the two values possible for alpha. Now, if I take alpha is equal to, if, see, beta was equal to 2, that was final. Now, if alpha is equal to 2 by 3, then gamma, alpha into gamma was equal to 4. So if this is equal to 2 by 3, then gamma will be equal to 6. And if alpha is equal to 6, then gamma is equal to 2 by 3. Right? So in either case, if you are having like alpha maybe 2 by 3 or alpha maybe 6, in either case, the gamma will take the another value. Okay. So what we had to find out was if I'm taking alpha as 6, beta is equal to 2 and gamma 2 by 3, or alpha 2 by 3, beta 2 and gamma 6. So you will have, you have to find out 3 alpha, 2 beta plus gamma. So this will give you 3 into 2 by 3 plus 2 into 2, and gamma was equal to 6, which will give you 2 plus 4 plus 6, that is equal to 12. Or if I'm taking these values, then 3 alpha plus 2 beta plus gamma can be written as 3 into 6 plus 2 into 2 plus 2 by 3, which is 18 plus 4 plus 2 by 3, 22 plus 2 by 3, which will be equal to 64 by 3. So these are the two possible values, that either it can be 12 or it can be 64 upon 3. Let's check with the options what we have. 64 by 3 is not in the options, but yes, we have 12. So that means this is the correct answer. Option C. Hope you got that. Next is question number 14. It says if Px is a quadratic polynomial with the real coefficients and P of x is equal to 0, has purely imaginary roots, then zeros of the polynomial P of Px are. See, one thing, Px is a quadratic polynomial which is having purely imaginary roots. First thing, if it is having imaginary roots, so let the Px be equal to x square plus a square is equal to 0, where a belongs to the real numbers. Now the roots will be, so roots are purely imaginary, so roots will be x is equal to plus minus iota a. Now, P of Px can be written as x square plus a square whole square plus a square, which is equal to x raised to power 4 plus a raised to power 4 plus 2a square x square plus a square. Okay. So this can be written as x raised to power 4 plus 2a square x square plus a square a raised to power 4. Now, the zeros of this polynomial, if you want to find out the zeros, like we have to find out the nature of the roots. To find out the nature of the roots, we have to go for the discriminant. And I hope you know the formula for the discriminant, that is equal to b square minus 4ac. Over here, b is equal to 2a square. So 2a square whole square minus 4. A is 1 and c is a square plus a raised to power 4, which is equal to 4a raised to power 4 minus 4a square minus 4a raised to power 4. This will cancel out and you will have minus 4a square, which is, of course, technically it's mathematically it's not correct, right? Because a square is going to be positive only, and a positive number by multiplied by 4 will give you negative only if it is imaginary. Like this is less than 0. If this is less than 0, that means the nature of the roots is non-real. Technically, it's not possible to have minus 4a square negative. So that means these roots, the nature of the roots is non-real. So let's check with the options. Only complex, non-real means complex numbers or the imaginary number. Only complex number of this form with a is equal to 0 and b is not. A is not equal to 0 and b is not equal to 0. So we have option D as the correct answer. Hope you got this. Let's move to the next question then. Question number 15. It says if alpha, beta, gamma are the roots of this equation and alpha plus 5, beta plus 5, gamma plus 5 are root of this equation, then the product of the root of the second equation. Okay. So basically what you have to find out, these three are the roots of the second equation. You have to find out their product. This thing. Technically, you have to find out this thing. Okay, let's start it from the scratch. Starting what we were given, alpha, beta, gamma were the roots of this equation. So first thing, alpha plus beta plus gamma, that is equal to minus coefficient of x square upon coefficient of x cube. That means minus of 12 upon 4, which is equal to minus 3. Now alpha, beta, beta, gamma, and this is equal to minus 7 upon 4. Alpha, beta, gamma is minus 165 upon 4. So I'll leave these three things as such. Okay. You are given that these three are the roots of this cubic polynomial. So let's multiply them. These three are the roots. Product of roots of ax cube, bx square, cx, d is equal to 0. R is alpha plus 5, beta plus 5, gamma plus 5. This will give you alpha, beta, gamma plus, see, there's a long calculation actually. Okay, let's do the calculation. So now you have alpha plus beta, alpha, beta, gamma. The next one will be, I'll take this 5 common, alpha, beta, beta, gamma, and gamma alpha plus 25. It will be alpha plus beta plus gamma. See, there's a long calculation which is involved. So solving this whole thing, alpha plus alpha, beta, gamma, plus the 5 will be there, alpha into beta plus beta into gamma plus gamma into alpha, plus 25 into alpha plus beta plus gamma. So solving these, multiplying these three factors, you will roots, you will get this thing. Now this thing plus 25 is also there. Alpha into beta into gamma was minus 165 upon 4 plus 5 into this was alpha beta plus beta gamma minus 7 upon 4 plus 25 into minus 3 plus 125. So this is equal to minus 165 upon 4 minus 35 upon 4. Minus 75 plus 125. So minus 75 plus 125, you can write it as 50 only, plus 50 only. Okay. So this will be 4 will be taken LCM, minus 165 minus this plus 200. So this is, it will cancel and you will have 0 as the answer. So that means we have option B as the correct answer. Hope you got this. Next is question number 16. The number of 3-digit odd numbers which are divisible by 3 that can be formed by using these digits when repetition is not allowed. Okay, so very first thing, the numbers which are odd 3-digit numbers, it should be. First condition, it should be 3-digit. Second, odd. And third, divisible by 3. These are the 3 conditions which should be fulfilled. Okay, let's try and frame. First thing, question number 16, the number of 3-digit odd numbers divisible by 3 that can be formed using these digits when repetition is not allowed. So many conditions are imposed in the question. Let's look. First is, it should be a 3-digit number. Second is, it should be odd. Third is divisible by 3. Then it should be formed by these numbers without repetition. 4 conditions are there. So very first thing, if I see it's an odd number, it's a 3-digit number. So 1, 2, 3. So if it is an odd number which has to be formed using these 6 digits, that means either the ones place can have, this is ones place, can have 1 or 3 or 5. Right? There are 6 digits and one position needs to have these 5. So how many ways are there? There are 3 digits. This can be done. Number of ways to have 3-digit. Okay, there is no need for writing 3 to have odd number. So that is, there are 1, 2, 3. There are 3 digits, so there are 3 ways. Now, this tens position, this can be occupied. 1 will be occupied, 1 digit will be taken up at the ones place. So we'll be out of the 6. I'll be left with 5 digits. So this tens place can be filled up in 5 ways. Similarly, hundreds place can be filled up in 5 minus 1, 4 ways. I hope you got this thing, right? So that means there are 60 odd numbers which can be formed from 3-digit. 3-digit odd number. Okay, so we have satisfied these 2 conditions. Now we are left with, it should be divisible by 3 and repetition not allowed. No repetition. Repetition is not allowed. So divisible by 3. Let's see the very first number. If I'll have 1 at the ones place, so the very first number can be 3, 2, 1. Right? The next number, 1 with 1 at the ones place and 2 at the tens place, it can be 6 to 1. Next, ones place 1, then 2 is like we are done with the 6 till here. We can't go beyond 6 because only 6 till 6 digits we have. So if I have a 3 over here, here you can have 2. This is divisible by 3. Now 1, 3, 5. Similarly, you will have, yeah. Similarly, if I'll take 1 over here and a 5 over here, there you can have 3, 1, 5, 6. You know the divisibility test of 3. The sum of the digits should be divisible by 3. Sum of digits should be divisible by 3. So taking that thing should be divisible by 3. So I'm taking that thing into note. If I'm taking ones place as 1 and tens place as 2, 3 and 4. If I took 4, I tried it, but there was no number in which I can have 4 at the tens place to let it be divisible by 3. Okay, the next one, 1, 6 over here and a 2 over here, 1, 6 and a 5 over here. So how many digits, how many numbers do you have over here? 1, 2, 3, 4, 5, 6, 7 and 8. Similarly, if I'll take 3 over here and 5 over here, you will end up having 8 numbers over here. See, in the examinations, in these type of examinations, you don't have so much of time that you keep on calculating each and every number, right? Similarly, if you are having eight numbers with 1 at the ones place, similarly you will get 8 numbers with 3 at the ones place and 8 numbers with 5 at the ones place. So 8 multiply 3, you have 24. So there will be 24 such numbers which will be 3-digit or numbers divisible by 3 having the digits 1 to 6 without a repetition. So you have option C as the correct answer. Hope you understood this. Let's move to the next question, number 17. So question number 17, this is a match question. There are 4 options and there are 5 list 2. There are 5 things in the list 2 and you have to match them. All right, let's go. So first one is the number of ways of not selecting n minus r things from n things and different things. This is, of course, this is equal to NCR, NC n minus r. So this will go with option A. Next one, second one, n minus r plus 1 into NCR minus 1. Okay, let's write it down. So here is option B I'm solving. N minus r plus 1 n multiplied. I'll write it again. So this is n minus r plus 1 multiply NCR minus 1. So this is n minus r plus 1 multiply NCR minus 1. This will be n factorial upon r minus 1 factorial multiply n minus r minus 1, which will be n minus r plus 1 factorial. So let's solve it further. You will have over here n minus r plus 1 into n factorial whole divided by r minus 1 factorial into n minus r plus 1 multiply n minus r factorial. So these two will cancel out. You will have n factorial upon r minus 1 factorial into n minus r factorial, which will be, you can write it as r into n factorial upon r factorial into n minus r. What I did over here is I multiplied the numerator and the denominator with r. Okay, so you will have r into n factorial upon r factorial into n minus r, which is actually equal to r into NCR. So this one will match with, let's see, option 3. This is B, right? Hope you got this. Let's move to the next one. The number of ways of selecting at least n minus r things from n different things. So number of ways of selecting n minus r things from n different things. Let's see. This can be done in NCR, NC n minus r plus NC n minus r plus 1, NC n minus r plus 2, so on till NCN. So this is equal to, you can write it as NCN plus NCN minus 1, NCN minus 2, so on NCN minus r plus 1, NCR minus NCN minus r. Okay, so this is equal to 1 plus this is also equal to NC1, NCN minus 1 is equal to NC minus NC1, NC2, so on till NCR. So let's check. This is option this C. Hope you got this. Let's move to the next question then. Not option actually. N minus R into whole this thing. Let's write it down. This was your C option. Now let's go for the D one. It says n minus r multiply n minus 1 r c r minus 1 plus n minus 1 c r. This is equal to n minus r n c r. Now n minus r whole multiplied by n factorial upon n minus r factorial upon r factorial. This is equal to n factorial upon, these two will cancel and you will see This n minus r factorial can be written as n minus r into n minus r minus 1 factorial, right? So n minus r and n minus r will cancel out and you will be left with n minus r plus, sorry, minus 1. I'll write it again. This is equal to n factorial upon n minus r minus 1 factorial into r factorial, right? Now let's multiply the numerator and the denominator with r plus 1. So if I multiply the numerator and the denominator with r plus 1, you will get n factorial upon r plus 1 factorial into n minus r minus 1 factorial. This whole multiplied with r plus 1. So this is equal to r plus 1 multiply NCR plus 1. Hope you got this. Okay, let's check this matches with this, right? So hope this is clear to you. This is the perfect matching. And let's check with the options, which one we have as the correct one. So A matched with the 5 and B matched with third. A matched with 5 and B matched with third. Okay, probably it's C. Let's check with the other ones. And C matched with 1, D matched with 2. Okay, we have this one. Option C is the correct answer. Hope you got that. Let's move to the next question, number 18. It says if L and M respectively are the coefficients of x raised to power minus 7 in this expression and the coefficient of x raised to power 7 in this expression, then N plus M is equal to. All right. So first of all, if you are given this thing, the general term of this expression, general term of ax plus b upon x square whole raised to power 11 is given by t r plus 1 is equal to 11c r multiply a r multiply b 11 minus r into x 3r minus 22. Now, if I'm taking x raised to power minus 7, then this 3r minus 22 will be minus 7, which will give you 3r is equal to 22 minus 7. This will be 22 minus 7 will be equal to 15. So r will be 5. Okay, now what is L? L is the coefficient of x raised to power minus 7. Let's go. L is the coefficient of x raised to power minus 7 in the given given equation, this one, right? So this is equal to 11c5 because we got r as 5 and ar, that is a raised to power 5, a raised to power r multiplied b raised to power 11 minus 5. Okay, this will be 11c5 into a raised to power 5 into b raised to power 6. This is L. Okay, now let's get to M. Now general term of bx square plus a upon x raised to power 11 is, let's write it here, tr plus 1 is equal to 11cr into a raised to power r into b raised to power 11 minus r into x raised to power 3r minus 11, right? Sorry, there's a mistake. This is 11cr, a raised to power, there's a mistake, 11 minus r. I'll rewrite it. Tr plus 1 is equal to 11cr, a raised to power 11 minus r, b raised to power r into x raised to power 3r minus 11. This is the one. Okay. Now for x raised to power 7, for x raised to power 7, 3r minus 11 will be equal to 7, which will give you r 3r is equal to 18 or r will be 6. Now, what was M? M was the coefficient of x raised to power 7 So m is the coefficient of x raised to power 7, which will give you 11c6 into a raised to power 11 minus 6 into b raised to power 6. Right. So 11c6, this is equal to 11 factorial upon, let's solve it, 11 factorial upon 6 factorial into, okay, I will not solve it. I'll just keep it right now like this only. Let it m be like this because we didn't solve L also, no? Yes. L was this and m came out to be this. Correct? What we had to find out is L plus m. Now let's go for that. So this is what you had to find out. To solve was L plus m. And it was 11c5. Let's see what L was. 11c5, a raised to power 5, b raised to power 6, plus this m is equal to 11c6, a raised to power 5, b raised to power 6. So you will take this common 11c5, 11c6, a raised to power 5, b raised to power 6. So this is equal to 11 factorial upon 5 factorial into 11 minus 5, which is 6 factorial, plus 11 factorial upon 6 factorial into 5 factorial into a raised to power 5, b raised to power 6. So this will be actually twice, right? You can write it as twice of. So this is actually equal to 12c6 A5, B6. I hope you remember this formula that NCR plus NCR minus 1 is equal to N plus 1 CR. So based on that formula, 11C5 plus 11C6, this will be equal to 12C6. I will not go in the detailed proof of it because I hope you already know the proof of this thing, this identity. Okay, so L plus N came out to be 12c6, a raised to power 5, b raised to power 6. Now, this is equal to, we have to look at the options. In all the options, you have ax plus b upon x square. So here comes your little experience, because if you have done a lot of mathematical problems, I can guess that it is about if I look at option B, x raised to power 6 in this thing, because there's a 12 involved. So I will not first of all go for any of these. I'll go for either A or B. And moreover, let's try with option B. I'll try to find out the coefficient of x raised to power 6 in this ax square plus b upon x. So now the coefficient of, I'm trying for option B. Now, coefficient of x raised to power 6 in ax square plus b upon x whole raised to power 12 is, you know, the general term again. General term was given by, this was ax square plus b upon x. So according to the general term, you will have x raised to power 6. If I will find out, general term will be given by 12cr, a raised to power r, b raised to power 12 minus r, x raised to power 3r minus 12. So looking at that, the coefficient of x raised to power 6 will be given by, this is 3r minus 12 is equal to 6, which gives r is equal to 18 by 3. That is equal to 6. Okay, so now the coefficient of x raised to power 6 will be equal to coefficient of x raised to power 6 will be equal to 12c6 into a raised to power r, this was r, 6 into b raised to power 12 minus 6, this is equal to 6. So 12 c6, b raised to power 6, a raised to power 6. That means L plus M is equal to, there is one, see, L plus M was equal to this, right? And this is, so this is, if I'm taking this as 1 and this as 2. Here is, the only difference is there is x a raised to power 5 and here is a raised to power 6. That means L plus M is equal to, from 1 and 2, L plus M is equal to half, or sorry, 1 by A the coefficient of x raised to power 6 in ax square plus b upon x whole raised to power 12. All right, so let's check with the options. We solved it for b. That means this is the correct one, right? Option B. See, one thing was clear, right? We can't take 11 because L plus M came to be 12 C6. So probably it has to be from 11, A and B. And from an A and B, the most one which was looking, the probable answer was looking to be option B. So I tried that and it worked. Okay. Next is question number 19. Hope you got that question. Okay, now this is given, this whole equation is given to you and you have to find out A plus B plus C is equal to what? So let's do this. X square minus 3x plus 2 whole divided by x minus 4, x minus 3 whole square is equal to. Now I'm taking the LCM. This will be A into x minus 3 whole square plus B into x minus 4 into x minus 3 C x minus 4, this whole divided by x minus 4 into x minus 3 whole square. So these will cancel from the LHS and the RHS and you will be left with x square minus 3x plus 2 is equal to A into x minus 3 whole square, B into x minus 3, x minus 4, C, x minus 4. Right? Now this is an identity, so it is true for every value of x. This is actually an identity, so this is true for all the values of x, identity. So this is true for all x. If this is true for all x, let's put x is equal to 3 in that equation. So you will get, if I'm putting x is equal to 3, you will have 9 minus 9 plus 2. See, this will be 0, so I'm putting this as 0, and this will be 0, so I'm putting this as 0. And you'll have c into 3 minus 4, which is equal to minus 1. So you'll have 2 is equal to minus c, or c is equal to minus 2. Okay, now let's put x is equal to 4 in this equation. So I'm putting x is equal to 4. This is 16 minus 12 plus 2. A, 4 minus 3, 1 square. So A, and this will be 0. This will be 0. So that means 0 plus 0. So from here, you got A as 6. Okay. Now let's put another one. X is equal to 0. So I'm putting x is equal to 0. This whole will be, okay, 0 minus 0 plus 2. Let's write it down. 0 minus 0 or 0 or whatever plus 2 is equal to, here was on the right hand side was, I'm putting x is equal to 0. So you will have A into 9 because minus 3 square plus B into minus 3 into minus 4 plus C into minus 4. We already calculated C and A. Let's fill. So 2 into, this is 6 nines are 54 and plus 12b, I don't know what it is, and c is equal to minus 2, so minus minus this will be plus 8. Okay, so this is, wait, 64. Wait. Yeah, this is 2 minus 54 minus 8. Okay, as doing it fine. So this will be minus 60 is equal to 12b, or b will be equal to minus 5. So we got all the values, right? We got A, B, and C. What was A, B, and C? Let's write down. A was 6, B minus 5, and C minus 2. You had to find out A plus B plus C. Now, the easiest one, let's go. So you have minus 1 as the answer. Right, let's check with the options. Option C is the correct answer. Hope you got this. Next is question number 20. So Okay, again, if x raised to power 3, this whole equation is given to you. You have to find out a plus b plus c plus d. Okay, again, the same thing. You will take LCM. So x plus 3, x squared plus 3 whole divided by x squared plus 1, x squared plus 2. This is equal to ax plus b multiplied by x squared plus 2 plus cx plus d x squared plus 1. This whole is divided by x squared plus 1, x squared plus 2. So they will cancel out, first thing. Now let's open up the brackets. X squared plus 3 will be equal to ax cube plus bx squared plus 2ax plus 2b. Cx cube plus x squared d plus cx plus d. Right? Now in the next step, I'll take some things which are common. So a plus c multiply x cube, b plus d, x square, 2a plus c, x, 2b plus d. Okay. Now the coefficient of x cube is 1 and here the coefficient of x cube is a plus c. So on comparing a plus c is equal to 1. Sorry, this was x square. Okay. So a plus c is equal to 0. And the next one is b plus d is equal to 1. 2a plus c is equal to 0 and 2b plus d is equal to 3. Let it be 1, 2, 3, and 4. So now from equation 1 and 3, I will have, see, this is very simple, right? From equation 1 and 3, a plus c is equal to 0 and 2a plus c is equal to 0. I'll subtract and I'll get minus a is equal to 0 or a is equal to 0. So if a is 0, then c is also 0. So that means a and c both came out to be 0. This is the first thing. Okay. Now I will take equations 2 and 4. So from 2 and 4, 2b plus d, let's subtract them. 2b plus d is equal to 3. B plus d is equal to 1. Minus, minus, minus. They will cancel. And you will have b is equal to 2. If b is equal to 2, you will solve d is equal to minus 1. So we got the values of b and d as well. Now easy. You have to find out a plus b plus c plus d. To solve was this, which is 0 plus 2 plus 0 minus 1. That is equal to 1. So this is the answer to our question, option D. Right? Next is question number 21. It says if A and B, A is greater than B, are acute angles, sine A minus B is this, sine B is this, tangent of A plus cotangent of A is. So you are given A is greater than B and both are acute angles. You are given sine A minus B is 16 by this, 65, and sine B is 5 by 13. Okay. So now, if this is this, then let's do the squaring on both the sides. Sine square A minus B is equal to 16 square upon 65 square. You know, sine square A plus you are aware of this identity. Sine square X plus cos square X is equal to 1. So from here, you can say cos square A minus B is equal to, I'll remove this square from here, root of 1 minus sine square A minus B. Correct. So similarly, I'll take cos B also. Cos B is equal to root of 1 minus sine square B. Okay. Sine square B is 5 upon 13 square. Now, cos A minus B is equal to root of 1 minus 16 square upon 65 square. And this will, when you will solve the whole thing, you will get the cos A minus B is 63 square upon 65 square, which is equal to 63 upon 65. This is cos A minus B. Similarly, cos B will be equal to 1 minus 5 square upon 13 square, which will eventually give you 13, like the whole thing you will solve, you will get 12 square upon 13 square. So cos B is equal to 12 upon 13. So I got cos A minus, I have four values now: sin A minus B, cos A minus B, sin B, and cos B. I have these values. Okay. So what we had to find out? Tangent of A plus cotangent of A. Okay. Now one more thing. I don't have sin A. Let's go for this. Sin A can be written as sin A minus B plus B. I'll take this one as the common one. So this is something sin X plus Y. And you know the value of it. This is given by sin A minus B cos B plus cos A minus B into sin B. Next, fill in the values. So sin A minus B is 16 by 65. This is given to you in the question. Multiplied cos B is 12 by 13 plus 63 by 65 multiply 5 by 13, which on the whole solution will give you 507 upon 845. That is 3 by 5. Sin A I got. Now cos A, I don't need to go for the whole thing again. I'll simply say cos A is equal to root of 1 minus sine square A, which is 1 minus 3 upon 5 square, which is equal to 25 minus 9 upon 25, which will be 4 by 5. Okay. Now I have everything. I had to find out tangent A plus cotangent A. So we did lots of preparation. Now the time to solve. Tangent of A, cotangent of A. This is sine A, cos A, cos A, sine A. Let's do some homework now. I will not just fill in the values. I'll try to make it simpler. Okay. This is sine A, cos A, sine square A plus cos square A, which is equal to 1 upon sine A, cos A. Now let's fill in the values. Sine A was equal to 3 by 5. Cos A 4 by 5. So you will have this as 25 by 12. So this is answer 25 by 12. Let's see. We have option A as the answer. Hope you got that. Next is question number 22. If tangent of A is 2 by 3, then sine 4A is equal to what? Very easy question actually. Sine A, okay, we are given tangent of A. You have to find out sine 4A. Sine 4A can be written as sine 2A plus 2A. Right? This is something of the form sine X plus Y. This is equal to sine 2A into 2A or twice of sine A. Twice of sine, sorry, you can say it sine 2 of 2A also. This is equal to 2 sine 2A into cos 2A, right? Now sine 2A is given by 2 tangent of A whole divided by 1 plus tan square A plus 1 minus tan square A upon 1 plus tan square A. So you have tan. Everything is given in tan and we have the tan. So very good. Let's go. Tangent of A, this is 2 by 3 and 1 plus tangent squared, this is 4 by 9. Plus 1 minus 4 by 9 upon 1 plus 4 by 9. This is equal to 8 by 3. Here will be 13 by 9 This will cancel. And you will have here 5 by 9, 13 by 9. I hope I'm doing everything correct, right? Yeah. Okay, so this is 9 and 9 will get cancelled, and you will ultimately have 24 by 13 plus 5 by 13, which will be equal to, I'll take the 13 common LCM. So this will be 29 by 13. Okay. Question number 22, tangent of A is 2 by 3, then sine 4A is equal to what? So very easy question. You can write down sine 4A as sine twice of 2A, which actually is equal to 2 into sine 2A. See, this also can be written as sine 2A plus 2A. Both the things are same, right? So this is equal to 2 sine 2A into cos 2A. Now sine 2A can be written as 2 into 2 into tangent of A upon 1 plus tan square of A, whole multiplied by 1 minus tan square A upon 1 plus tan square A. Everything is in multiplication, so let's go. So 2 into tangent of A is 2 by 3 multiplied by, this whole is divided by 1 plus tan square is 2 by 2 upon 3 square, which is equal to 4 by 9 multiplied by 1 minus 4 by 9 upon 1 plus 4 by 9. Next, this will be equal to 8 upon 3 whole divided by 13 upon 9 multiplied by 5 upon 9 whole divided by 13 upon 9. So first thing, let's put it in the right term. So 8 by 3 multiply 5 by 9 whole multiplied by 9 upon 13. 9 upon 13. So this will cancel out. This will cancel out at 3. And I think no further calculations are there possible. No. So this is equal to 120 upon 169. Let's check with the options. We have option B as the correct answer. Hope you understood this. Next is question number 23. Again, a trigonometry problem, root of cos 45. Okay, this whole thing is there. We have to solve it. Let's understand this. Root of cos 45, cos 56 plus cos 58 minus cos 66 divided by root 2 into cos 28, cos 29, sine 33. Cos 45, the easiest one. Let's start with it. We know cos 45 is equal to 1 by root 2. So I'll keep it here. This is plus cos 56 degree, cos 58 degree minus cos 66 degree. Whole divided by root of 2 into cos 28, cos 29, sine 33 degree. They will cancel out and you will be left with 1 minus, I'll collect it, 1 minus cos 66 degree plus, see, this is cos A plus cos B. Now cos A plus B, cos A plus cos B is given by 2 cos A plus B upon 2 cos A minus B upon 2. Now using this 56 plus 58 whole divided by 2, this will give you cos 57 and cos 50. Yeah, this is 58. Okay, so cos 1 degree. Okay, whole divided by root of 2. I will not touch the denominator. Cos 28, cos 29, sine 33. Now 1 minus cos 66 can be written as, see, 1 minus cos 66 can be written as 2 sine square 33. I hope you remember this formula. 1 minus cos 2a is equal to 2 sine square a. Okay. So using this, you have here 2 sine square 33 degree plus 2 sine 57. Cos 57 can be written as cos 90 minus 33. Yes, cos 90 minus 33. So this is equal to sine 33. So I'll write it to sine 33 and cos 1 degree upon root 2 cos 28 cos 29 sine 33 degree. Okay, I'll take the sine 33 common from the numerator. So you will have sine 33 degree to sine 33 degree plus cos 1 degree upon root 2 cos 28 cos 29 sine 33. This will cancel out. You'll be left with, and even this will cancel out. You'll be left with root 2 sine 33 plus cos 1 degree. So sine 33 again can be written as cos 57 plus cos 1 degree whole divided by cos 28 and cos 29. Now this is equal to, again the same thing. This is cos A plus cos B. Root 2 into 2 cos 57 plus 1, 58 divided by 2. This will be cos 29 degree. And 57 minus 1, this will be 56 divided by 2. This will be 28 degree. Whole divided by cos 28, cos 29. They will cancel out. And you will have 2 root 2 as the answer. Hope you got this. The whole thing, we have option B as the answer. Hope you understood this well. Next is question number 24. If theta is equal to pi by 12 and x is this whole expression, then cos hx is equal to. Okay, if theta is equal to pi by 2, let's write down this is x is equal to log of cot of pi by 4 plus pi by 12. So log of cot of this will be, on solving 12 will be the LCM. So 3 plus 4. Okay, this will be pi by 3. Log of cot 1 pi by 3 is equal to 1 by root 3. Now you have to find out cos hx. This is given by e raised to power x, e raised to power minus x upon 2. X was equal to this. So let's fill in e raised to power log of 1 by root 3 plus log of e raised to power minus log of 1 by root 3. This whole divided by 2. This will be 1 by root 3 plus root 3. You know, this thing, this minus will go. See, minus log 1 by 3. Root 3 can be written as log of 1 by root 3 raised to power minus 1, which will be equal to this. Okay. So this whole is divided by 2, which will give you 1 plus 3 upon 2 root 3, which will be 4 upon 2 root 3 or 2 upon root 3. Hope you understood this. So we have option A as the answer. Right? Next question number 25. You have 2 cos h x plus y sin h x minus y plus sin 2y sin h 2y is equal to what? So first thing, sin hx is e raised to power x minus e raised to power minus x upon 2, and cos this is e raised to power x upon 2. Okay. Now 2 cos h x plus y sin h x minus y plus sin h 2y is equal to 2 into e raised to power x plus y minus, here was plus, e raised to power minus x plus y whole divided by 2 multiply e raised to power x minus y minus e raised to power minus x minus y whole divided by 2. So this is equal to, this is plus sine 2y. This can be written as e raised to power 2y minus e raised to power minus 2y upon 2. Now, let's expand this. First of all, this 2 and 2 will get cancelled, and you'll be left with e raised to power x plus y, which can be written as x plus y plus e raised to power minus x minus y multiply e raised to power x minus y minus e raised to power minus x minus y plus e raised to power 2y minus e raised to power minus 2y. This is upon 2 and this whole thing is upon 2. So this is e raised to power x plus y multiply e raised to power x minus y plus e raised to power x, okay, this is minus e raised to power x plus y into e raised to power minus x minus y plus e raised to power minus x minus y multiply e raised to power x minus y minus e raised to power minus x minus y multiply e raised to power minus x minus y. This whole is divided by 2 plus e raised to power 2y minus e raised to power minus 2y divided by 2. Now, bases are same, powers will be added and you will have here e raised to power 2x and this one will have e raised to power 0. This is minus. So this is, yes, this will be e raised to power 0. And here x and x will cancel and you will have e raised to power minus 2y. And here is minus e raised to power minus 2x minus 2y. This whole divided by 2 plus e raised to power 2y minus e raised to power minus 2y upon 2. Now let's 2 common take the LCM. So you will have e raised to power 2x plus e raised to power minus 2y minus e raised to power, this will be equal to minus 2x minus 2y plus e raised to power 2y minus e raised to power minus 2y. So these two will cancel first. Okay. And you will have here question number 25, 2 cos h x plus y sine h x minus y plus sine h 2y is equal to what? So, you know this sine hx is given by e raised to power x minus e raised to power minus x upon 2. And cos hx is given by e raised to power x plus e raised to power minus x upon 2. Now, let's get back to our equation. We were given 2 cos h x plus y sine h x minus y sine h 2y. So this can be written as 2 into e raised to power x plus y plus e raised to power minus x minus y upon 2 multiply e raised to power x minus y minus e raised to power x minus x plus y. Yeah. Whole divided by 2 plus sine h2y will be given by e raised to power 2y minus e raised to power minus 2y upon 2. So first thing, these two things will get cancelled. And let's multiply the numerators. You will have e raised to power x plus y multiply e raised to power x minus y minus e raised to power x plus y multiply e raised to power minus x plus y plus e raised to power minus x minus y multiply e raised to power x minus y minus e raised to power minus x minus y multiply e raised to power minus x plus y. This whole thing is divided by 2 plus e raised to power 2y minus 2y upon 2. Next, Bases are same, powers will add. So you will have e raised to power 2x minus e raised to power 2y plus e raised to power minus 2y minus e raised to power minus 2x whole divided by 2 plus e raised to power 2y. Actually, I'll combine this, okay? Let's take the LCM here only. Minus this. So this thing will cancel out and even this will cancel out and you will be left with e raised to power 2x minus e raised to power minus 2x divided by 2, which is sine h 2x. Let's check with the options. We have option A as the answer to the question. Hope you got this. Next is question number 26. In a triangle ABC, if b plus c square into sine square a by 2 plus this whole thing, then this whole equation is there, then you have to find out the value of k. So in a triangle ABC, you are given b plus c square into sine square a by 2, b minus c square, cos square a minus 2 is equal to k into this. So I'll take the whole question into the terms of sine now. Okay. So for that, first thing, b plus c square sine square a by 2 plus this. Now cos square a by 2 can be written as 1 minus sine square a by 2. And 1 minus cos 2a is equal to 2 sine square a. I hope you know this formula, right? Okay. So next thing, I'll open up. So I'll have b plus c whole square into sine square by 2 a by 2 plus b minus c whole square minus b minus c whole square sine square a by 2 is equal to k into 2 into sine square a. Now, let's combine this. You will have b minus c square plus b plus c square minus b minus c square. This whole thing multiplied by sine square a by 2 is equal to 2k sine square a. Now, let's put some values. On putting, sine a by 2 is given by s minus b, s minus c upon b into c. Also, sine a is a upon 2r. Now, let's fill in. You will have this as b minus c whole square plus 4bc. See, you will subtract this thing, right? I hope you know on solving this, you will get 4bc. Okay. I don't think I need to go for the whole explanation. I'll probably go for this 4bc. Okay. So this is 4bc into that was square. So you'll be left with s minus b, s minus c upon b into c. This is equal to 2k into a square upon 4r square. This is b minus c square plus 4. Now this bc and bc will cancel and you will have s minus b s into s minus c. This is given as a plus b plus c upon 2 minus b into a plus b. See, this is equal to minus c. This is equal to k into a square upon 2r square. Okay. Now, let's solve it further. You will get here b minus c whole square plus a plus c. So this will be, I'll take the LCM, minus 2b plus b. This will give me minus b. Okay. And the twos will cancel. Okay. I'll write it down. Multiply 2 and here will be a plus b minus c upon 2 is equal to k into a square upon 2r square. So these will cancel out and you will have b minus c square plus a minus b minus c, whole thing close, a plus b minus c. Okay. Now this is something x minus y into x plus y. So this can be written as a square minus this is equal to k into a square upon 2r square. Now let's open it up and you will have minus b minus c whole square is equal to k into a square upon 2r square, which will give you, these two will cancel, a square is equal to k a square upon 2r square, or 1 is equal to k upon 2r square, or k is equal to 2r square. So let's check. K is equal to 2r square. Option B is the correct answer to the question. Hope you got this. Next is question number 27. In a triangle ABC, B7, C is this, A is this, then A sine B sine C is equal to. Okay, so first thing let's write down in the triangle, you are given B is 7, C 4 root 3, and A is pi by 6. Let's go with first thing. I'll say, if you know cos A is equal to B square plus C square minus A square upon 2BC. So cos pi by 6 can be written as B square, which is equal to 49. C square, which is 4 root 3 square, 16 into 3, 48. And A square, I don't know, I'll write it as such, into 2B, 2 into B into C. This will give me 97 minus A square upon 56 root 3. Cos pi by 6 is equal to root 3 by 2. So, okay, this will be cancelling. This will be 28. So, 3 multiplied and root 3, this will be 3. 3 multiplied 28 is equal to 97 minus A square. On solving this whole thing, you will get A square is equal to 13 or A is equal to root of 13. Okay, now using the sine rule, you know sine A upon B is equal to, sorry, sine A upon A is equal to sine B upon B is equal to sine C upon C. So A was pi by 6, sine pi by 6. A we just calculated, this was root of 13, is equal to sine B. I don't know that, but B is 7. Sine C also, this is 4 by root 3. So from here, you can calculate sine B. Sine pi by 3, which is sine 60, this is equal to root 3 by 2. Sorry, this is equal to 1 by 2. Sine pi by 6 is sine 30. So 1 by 2 into 1 by root 13 into 7. This is equal to sine B, which is equal to 7 upon 2 root 13. Similarly, sine C is equal to 1 by 2 into 1 by 13, root of 13, multiply 4 root 3 is equal to, this will cancel out at 2. So 2 root 3 upon root 13. I hope this is the one. Yeah. So this is equal to sine C. Now what you had to find out in the question was A sine B sine C. So to solve was A sine B sine C. A was equal to root of 13. Sine B is 7 to root 13. And this is equal to 2 root 3 upon root 13. So first thing, this will cancel out this and this will cancel with this. And you will left with 7 root 3 upon root 13. Let's check with the option. 7 root 3 root 13 is option D. Hope you understood this. Next is question number 28. In a triangle ABC, if BC is the hypotenuse, then R2 plus R3 is equal to what? So let's make it. First of all, this is a right angle triangle. ABC. BC stands to be the hypotenuse. Okay, so in this case, first thing, R1 is given by delta upon S minus A. R2, this, and this. Right? What do we have to find out? R2 plus R3, which is delta upon S minus B, S minus C. So I'll take this common. S minus B, S minus C. This is equal to delta 2S minus B minus C upon S minus B, S minus C into S into S minus A, S into S minus A. I'll multiply the numerator into denominator with S into S minus A. So this will become delta A into S minus A upon delta square. Now, how all this happened, A plus B plus C upon 2 is equal to S. And if I have A plus B plus C is equal to 2S, right? See, 2S minus A is equal to 2S minus B minus C. So I can write down, for this, I can write down this A. Similarly, you know that area is equal to, or delta is equal to root of S into S minus A, S minus B, S minus C, right? So this is S into S minus A, S minus B, S minus C. So this is equal to delta square. Okay. So I hope you got till here. Next, this and this will get cancelled and you will have R2 plus R3 is equal to A into S minus A upon delta, which is actually equal to A upon tan angle A by 2 is equal to, this is A. Now why? Because A is given to you as pi by 2. This is a right angle triangle. BC is the hypotenuse. A is the 90-degree angle. Right? So tan 90 by 2 is tan 45 and this is 1. Okay. Right. So that means we got our answer as A. So option B is the correct one. Hope you understood this. Next is question number 29. In a triangle ABC, D and E divide the sides B, C and C in the ratio 2:1. Let's draw the figure first for this. So this is a triangle ABC. Now it's saying D and E divide the side BC and CA. So D, let it be D, and E. D and E divide the sides BC and CA. Okay. In the ratio 2:1. Two is to 1. And next, what it is given, if P is the point of intersection of AD and BE, then the ratio in which P divides AD is, okay, fine, you have to find out this ratio. AP is to PD ratio. All right. So I hope you're clear with the figures. Now let A, B, C, D, E, and P have position vectors A, B, C, D, E, and P, respectively. Now, given D and E, divide the line segment, divide BC and AE in the ratio 2:1. Then by the section formula, D is equal to 2C plus B upon 2 plus 1, right? See, this is 2, this is 1. So 2C plus B upon 2 plus 1. This will give you 3D is equal to 2C plus B. Similarly, E is equal to C plus 2A upon again 2 plus 1, which gives you 3E is equal to C plus 2A. So now from these equations, let's solve it. From these two equations, you have 3D minus B is equal to 2C from equation 1. And from equation 2, you have 3E minus 2A is equal to C, which let's multiply both the sides with 2. You will have 6E minus 4A is equal to 2C. Now equating both of them, you will get 3D minus B is equal to 6E minus 4A, or 3D plus 4A is equal to 6E plus B. 3D plus 4A upon 3 plus 4 is equal to 6E plus B upon 6 plus 1. LHS is the position vector of the point which divides the line AD internally in the segment 3:4. Similarly, RHS is the position vector of the point which divides the line segment BE. This was for the AD in the ratio 6:1. This was 3:4. Now, P is the point of intersection of both AD and BE. This was the point P. This was the point of intersection. Therefore, P divides AD internally in the ratio 3:4. And P divides BE internally in the ratio 6:1. I hope you got this thing, right? So looking at this, AD was being divided in the ratio 3:4 and BE was divided in the ratio 6:1. So what we were asked in the question, actually, we were asked the ratio in which P divides AD. So AD is divided in the ratio 3:4. That means we have option B as the correct answer to the problem. Hope you understood this. Next is question number 30. This says if the points with the position vectors I minus 2j. Okay, these are the position vectors 1, 2, and 3. And these are coplanar, then A is equal to what? Let's write it down. First of all, let the position vector A be I cap minus 2j 3k and B is equal to 2I plus 3j minus 4k. C is equal to minus 3I plus j. Sorry for this. Okay, I'll have to rewrite it. It's okay. A was equal to 2I plus 3. Sorry. A is equal to I minus 2j plus 3k. B 2I plus 3j minus 4k. And C minus 3i j minus 5k. D is a I to j 4k. Okay, now they are coplanar. First of all, let's solve for a b, and then I'll go for AC and then AD. 2i minus I plus 3j minus minus plus this minus 4k minus 3k. This is equal to I 5j minus 7k. This is AB. Now let's solve AC. Similarly, on solving the same way, you will get AC is equal to minus 4i plus 3j minus 8k, and AD a minus 1i plus 0j plus k. Now you are given that A, B, C, D are coplanar. So if they are coplanar, that means their determinant is, if I'm taking these position vectors into a determinant form, that is 0. So if you are given that A, B, C, D are coplanar. So if they are coplanar, that means AB, BC, not BC, sorry, AB, AC, and AD. This is equal to 0. So according to the position vectors, let's make the determinant of it. Means therefore, determinant of 1, 5, minus 7, minus 4, 3, minus 8, a minus 1, 0, 1 is equal to 0. Let's find out the determinant. So first thing, 1 into 3 plus 8 minus 5 into minus 4 plus 8 into a minus 1 minus 7 into 0 minus 3a minus 1 is equal to 0. So this will give you 11 minus 5 into, this is minus 4 plus 8a minus 8 minus 7 minus 3a plus 3 is equal to 0. 11, this is minus 12, and this is plus 60. 40a minus minus plus 21a minus 21 is equal to 0. So let's solve it further. You will have minus 19a. This will be minus 10 plus 50. Give me a minute. There is a small mistake I did. 0 multiplied by 8. This is supposed to be 0 over here. Okay. And then this was 3 and this is also 3. Let's solve it. So you will have here, this will be 63 minus 21, which is equal to 42. Okay. So this is 42 is equal to 0. 19a. So a will be equal to 42 upon 19. Okay. So this is the value 42 upon 19. Option B is the correct answer to this question. Hope you understood this. Let's move to the next question. Question number 31. If P is the point on the line parallel to this vector and passing through the point A, whose position vector is given by this, and AP is 21, then the position vector of P can be what? First of all, equation of the line will be given by, if the equation of the line L, it will be given by R is equal to A plus lambda B. Where A is this, A will represent this vector. So you can also write down R as iota, sorry, not iota, I cap, 2j cap minus 2k cap plus lambda 2 I cap minus 3j minus 6k, which represents this vector. Now let P be any point on the line L. Here P is, it's given that P is on this line. So P is any point on this line, right? Therefore, P will be given by 1 plus 2 lambda. Similarly, 2 minus 3 lambda minus 2 minus 6 lambda. And A, looking at this vector, A will be given by 1, 2 minus 2. You are given that AP is equal to 12. So let's write it. You know the distance formula. This will be given by root of 1 plus 2 lambda minus 1. This will be 2 lambda square. Then 2 minus 3 lambda minus 2. This will be minus 3 lambda square. Then minus 2 minus 6 lambda plus 2. This will be 6 lambda minus 6 lambda square is equal to 21. So let's solve it. 4 lambda square plus 9 lambda square plus 36 lambda square is equal to 441. This is equal to 49 lambda square is equal to 441. Or it would have been better, right, if I would have kept the under root over here. Okay, let it be 21 only. So 7 lambda is equal to, I'm taking it like plus minus 7 lambda is equal to 21. So from here, you can say that the modulus of lambda is equal to 3, which means that lambda can be equal to plus minus 3. Hope you got this thing, right? Now, at lambda is equal to 3, what the coordinates of P will be? Let's write it here only. At lambda 3, P will be given by 7, comma, minus 7, comma, minus 20. These are the coordinates of P. We had to find out the position vector of P. So let's find out the position vector of P. Let's write it here. Position vector of P will be 7i cap, 7j cap, minus 20k cap. So this was for when lambda is equal to 3 and when lambda is equal to minus 3. The same coordinates of, here the coordinates of P were 7, minus 7 and minus 20. And here the coordinates of P will be minus 5, 11 and 6. And the position vector of P will be position vector of P in case when lambda is minus 3 is equal to minus 5 I cap, 11 j cap, 16 k cap. Now let's check out of these two, like these are the two possible answers. Out of these two, which one is there in the options? I don't have the 7 I cap minus 7 j cap one in the options, but definitely I have this one in the options. So option C is the correct answer. Hope you understood this. Next is question number 32. It says let A be the vector in the plane containing the vectors this and C, B is equal to this and C is equal to this. If A is perpendicular to I plus J plus 3K and its projection on B is 3 root 6, then modulus of A vector square is. Okay. So first thing, let's suppose A vector to be AI cap, B and C. Now it's given that A be the vector in the plane containing these two vectors, right? Therefore, if A is the vector in the plane which is containing these two vectors, then what do you have? A dot B cross C will be equal to 0. Now, this is A. What was B? Let's write B over here. It was I to J and K. And C was 2I minus J plus K. So now let's write it down. This will be A, B, C and 1, 2, 1, 2 minus 1, 1. This is equal to 0. Now, let's find out the determinant of it. You will have 2 into 2 plus 1, that is equal to 3, minus B, 1 minus 2 plus C minus 1 minus 4 is equal to 0, which will give you 3A plus, this will be equal to 2B. Sorry, this is equal to B. 1 minus 2 minus 1. Okay. And over here, minus 5C is equal to 0. Now, let's name this one as 1. Next, it is given about A, that A is perpendicular to this and its projection on B is this. So, next thing, it is given A is perpendicular to this vector. Second case, A is perpendicular to I plus J plus 3K. A is perpendicular to this, which means A dot I J K is equal to 0, which will give you, on solving, A plus B plus 3C is equal to 0. I hope you know this. A vector was given by A I cap, B J cap, C K cap, when it was having the dot product with I cap, J cap, 3K cap. So you will have A into 1 plus B into 1 plus C into 3. Okay. So here comes A plus B plus 3C is equal to 0. Now let's name this as number 2. Third thing was given that the projection on B is 3 root 6. Projection, if A is perpendicular to this vector, and its projection on B is this. So third thing, projection of A on B is 3 root 6. Now, projection of A on B means A dot B upon modulus of B is equal to this, right? Same thing, A was this and A is this vector, and B is this vector. B was I to J and K. So looking at that, you will say A plus 2B plus C upon the modulus of B. B is 1 plus 2 square 4 plus 1 is equal to 3 root 6. I hope you know the modulus, right? Modulus B vector was given by this. This was B vector. So its modulus will be given by 1 square plus 2 square plus 1 square. So let's solve it further. You will have A plus 2B plus C is equal to 3 root 6 into root 6, which is equal to 18. Okay. So this be number 3. Now I think you can solve it, right? I have 3 variables, which were A, B, and C, and you have 3 equations. This is third one, this is second one, and this is the first one. Correct? Now, on subtracting 2 from 1, on subtracting equation 2 from 1, you will have 2A minus 8C is equal to 0, or A is equal to 4C. Now on multiplying 2 in equation 2 and subtracting from equation 3. On multiplying 2 in equation 2 and subtracting equation 3. Right? You will have A plus 5C is equal to minus 18. And you have 4C plus 5C is equal to minus 18, which will give you C is equal to minus 2. Right? And if C is equal to minus 2, I'll get A is equal to minus 8. So now we have to find out B. Let's go for B. On putting A and C in third equation, you will get A is equal to minus 8I 14. Um, sorry for this. So on putting A and C in equation 3, you will get, what is equation 3? This was the one. A plus 2B plus C is equal to 18. A plus 2B plus C is equal to 18 minus 2 minus 8 plus 2B is equal to 18. And this will be 2B is equal to 28 or B will be 14. So we got all the three values A, B, C. Now A vector will be given by minus 8 I cap plus 14 J cap minus 2 K cap. And this is what we needed. Okay, we needed to find out this. Let's go for this. So this is given by root of minus 8 square plus 14 square plus minus 2 square, which is equal to 64. And this is 196 and 4. Actually, we needed to find the square, right? So this will be given by 264. So we have option D as the answer. End the question, right? So better be hurry up because you need to solve such type of questions in the paper. You really need to be fast. Let's move to the next question. Hope you understood this one. Question number 33, the Cartesian equation of the plane passing through the point this. So lots of problem on the vectors we have. And perpendicular to this vector is simple question it is, right? You are given the point. The given point is on the plane. 1, minus 2, and 3. For that, the vector can be represented as I minus 2j plus 3k. Now, perpendicular vector to this plane. Perpendicular vector to this plane will be given by minus I plus 2j plus minus 3k. Now, you have to find out the equation of the plane. So, equation of the required plane will be equation of the required plane will be, see, it is R multiply N, which is here actually A multiplied by N, which can be given by Xi, Yj, Zk in dot product with minus I plus 2j minus 3k. So they are having the relationship of the dot product. So see, here the A is this actually. So it will be given by I minus 2j plus 3k multiply minus I plus 2j minus 3k. Okay, now this will be 1 into minus 1. Yeah, so 1 into minus 1, this will be minus x plus 2y minus 3z. Question number 33, the Cartesian equation of the plane passing through this point and perpendicular to this vector is. So lots of problem on the vectors we are having, but this one is pretty easy. You are given the point on plane 1, minus 2, 3. For that, the vector can be given as I minus 2j plus 3k. Now the perpendicular vector to the plane will be given by minus I plus 2j minus 3k. So the equation of the required plane is equation of the required quiet plane r dot n is equal to here it is a dot n. So r, like this is the one I want to find out. So I'm representing this as xi, yj and zk. This is in dot product with minus I cap plus 2j cap minus 3k cap. This is equal to I cap minus 2j cap plus 3k cap dot minus I plus 2j minus 3k. So let's do the multiplication. You will have minus x plus 2y minus 3z is equal to minus 1, minus 4, minus 9, which is equal to minus 14. So you will have x minus 2y plus 3z is equal to 14. This is the required equation. And let's check with the options. I have option B as the, option B as the correct answer. Hope you understood this. Let's move to the next question then. Question number 34. It says, let A be this factor, B be this factor, C is this factor, and D is this factor. These are the four factors, and let L is equal to B dot C and M is C dot A vector. Then this whole matrix is equal to what? So you're given four matrices, vectors. The first one is A, I, J, I plus J plus K. B is given as I minus 2J plus K. C, I plus 3J minus 2K. And D, 2I plus J minus K. These are the four factors. Now, the first thing you are given that L is the dot product of B and C vector. You know this is B and C. Let's do the dot product of both the vectors. So you will have 1, 1, which is 1 multiplied 1 is equal to 1. And minus 2 into plus 3, this is equal to minus 6, which is equal to, minus 2 as well. So which is equal to minus 7. This is L, and M is the dot product of C and A vector. C vector is 1 plus 3, I plus 3J minus 2K. A vector is I plus J plus K, which will give you 1 plus 3 minus 2, that is equal to 2. So you got the values for L and M. Now we have to go for this matrix. This was M dot, not dot, MB. Actually, M is a constant over here, so no problem at all. MB plus LAB D. Sorry. So this can be written as MB, B, D, and LA, BD plus between them. Right? I'll take M common from here. This will be B, B, D, and L from here. A, B, D. You know this BBD, this will be valued to be 0. So you will be left with L, A, B, D. L was equal to minus 7. We just calculated. And let's write down ABD. This was 1, 1, 1. B was 1. Actually, these are the vectors, okay? Yeah, these are the vectors. Let's write down. So everything is in the vector form. Okay, so this will be 1 minus 2, 1, then 2, 1, minus 1. Let's solve this. You will have minus 7 and 2 minus 1, which is equal to 1, minus 1, minus 1, minus 2, plus 1, 1, minus 4. Plus 4, sorry. Okay. So this will be brackets close, minus 7, 1, plus 3, plus 5, that is equal to minus 63. So this is the answer to the question minus 63, and we have option B as the answer. Hope you understood this. Let's move to the next question, number 35. If x bar is the mean of n observations starting from x1 to xn, then the mean of absolute deviations for these observations from x bar is, okay. So first thing, you are given that mean is equal to this, right? Mean of absolute deviations is given by sigma, since it's from this, so x minus x bar upon this upon 2. Okay. Now this is actually, this is equal to mean deviation of the data. There's a formula for mean deviation of the data, right? So that means we have option B as the correct answer to the question. Hope you understood this. Let's move to the next question, number 36. A cube having edge of length 5 centimeters painted on all faces and then is cut into equal cubes of unit volume. A small cube is selected at random and found that a piece of it is painted, then the probability that two more faces of it are also painted is. So first thing, you have volume of cube with the length edge, a volume of cube of edge 5 centimeter, and all faces are painted is 5 cube. That is side cube, which is equal to 125 centimeter cube. Now let the cube be divided into n small cubes of unit volume. Let cube is divided into n cubes of unit volume. So that, this volume of the big cube will be equal to n multiplied by volume of one small cube. One small cube. That means 125 is equal to n, which is, this is equal to 1. It's given that this is having unit volume. That means n is equal to 125. Now, it's given a small cube is selected at random and found that a face of it is painted. Then the probability that two or more faces of it are also painted is. Now, number of cubes whose three faces are painted is equal to 8, right? Similarly, number of cubes whose two faces are painted this will be 36. Now the number of cubes whose L faces are painted this is equal to 54. We had to find out the number of cubes, what the probability that two or more faces of it are also painted. Okay, fine. So similarly, I can say the number of cubes whose zero faces are painted. Whose zero faces are painted will be given by, out of 125, I'll subtract 8, 36, and 54, which will give me 27. So now we had to find out the what we had to find out, then the probability that two or more faces of it are painted. So the required probability is equal to is equal to 3 faces painted cubes divided by cubes whose at least one face, cubes whose at least one face is painted. Okay, so this is equal to 8 upon cubes total. It was 8 plus 36 plus 54, which is equal to 8 upon 98, which will be 4 upon 49. So let's look at the options. 4 upon 49 is option B. So I have option B as the correct answer. Hope you understood this. Let's move to the next question. Question number 37. A pair of dice is thrown twice in succession. The probability of getting prime numbers on both the dice in the first throw and the composite numbers on both the dice in second throw is, there are 6 numbers on one dice, right? 1, 2, 3, 4, 5, 6. This is for the first dice, and second one also has the same numbers. Now, when the 2 dice are thrown in succession, so it is asked the probability of getting a prime number. So let's write down the prime numbers and composite numbers first. On a dice, the prime numbers are 2, 3, and 5. Composite are 4 and 6. Now, probability of getting prime numbers on both dice in the first throw. Pairs of prime numbers on both the die on first throw. This is 2, 2, 2, 3, 2, 5, 3, 2, 3, 3, 3, 5. Then 5, 2, 5, 3, and 5, 5. Now that means how many pairs are total? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 pairs. Let's go for the composite numbers also. Pairs of composite numbers on both the die in second throw. 4, 6, 4, 4. This is the one. So how many total? 4 pairs. Right. Now the question was required probability. Let's go for the question once again. The question was, what is the probability of getting prime number on the first and the composite number on the second throw in the succession? So that means the required probability is 9 upon total are 36 rows, right? You know the pair, 6 on this and 6 on this. So total pairs were got to be 36. Okay. So this is 9 by 36, multiply 4 by 36, which will be 1 upon 36, right? That's the answer to the question, option C. Hope you understood this. Let's move to the next question, number 38. 3 balls are drawn one after another without replacement from an urn containing, okay, 4 red, 5 blue, and 6 yellow balls. The probability of getting 3 different colored balls is, so first thing, how many total balls we are having in the container? Total balls is equal to 4 plus 5 plus 6, which is equal to 15. So the number of ways of selecting 3 balls, number of ways of selecting 3 balls will be 15C3. Number of ways of selecting 3 different colored balls. Of selecting 3 different colored balls is equal to 4C1, because out of 4, 1 will be picked. Out of 5, 1 will be picked. Out of 6, 1 will be picked. So you have to find out the required, what is the probability of getting 3 different colored balls is. So 4C1, this is equal to 4 into 5 into 6. Okay, I'm not going to solve it. I'll just leave it as such. Now the required probability is given by 4 multiply 5 multiply by 6 upon the total one, which was 15C3, right? So 4 multiply 5 multiply 6 is equal to 15 factorial into 3 factorial into 12 factorial. So this is 4, 5, 6 into 3 into 2 into 12 factorial. This is 15 into 14 into 13 into 12 factorial. These two will cancel, and this will cancel with this. Next is 2 will cancel with 14 at 7. So you will have 24 upon 91. This is the answer to the question. That's option B. Hope you understood this. Let's move to the next question, number 39. It says 2 balls, again a probability question. 2 balls are drawn at random from a box containing 5 black balls, 3 red balls. If the random variable x denotes the number of white balls drawn, then the mean of x is. Okay, so the bag is containing 5 black plus 3 white balls. Right? Now, random variable x denotes the number of white balls drawn. X denotes number of white balls drawn. So x0, this will represent no white balls drawn. X. Okay, for that, the probability of getting that is 0 white balls is 3 out of 3 C. I'll select no balls. So 3C0 multiply 5C2 whole divided by 8C2. Why? Because there were total 8 balls. Okay. And I have to pick up 2 balls. So this will be given by, and you will solve it, you will have this as 1 multiplied by 5 factorial upon 2 factorial into 3 factorial into 8 factorial upon 2 factorial into 6 factorial. Let's solve it. First of all, this will cancel, and 5 factorial, 5 into 4 into 3 factorial into 6 factorial upon 3 factorial into 8 into 7 into 6 factorial. This will cancel, and this will cancel at 2. So you will have here 5 upon 7. 5 upon 14. Okay. Now, probably if I'm saying the 1 white ball is drawn, this is 1 white ball is drawn. So the probability of getting that is 5C1 into 3C1 upon 8C2, which on solving will give you 15 by 28. Okay. So I'll do one thing. I'll put it as 10 by 28. Okay. Similarly, for x2, that means 2 white balls drawn. This probability is given by 3C2 into 5C0 upon 8C2, which on solving will give you 3 upon 28. Now you have to find out the mean. What do you have to find out? Mean of x. Now, mean of x is sigma xi p xi. This is equal to, first is 0 into 10 upon 28, 1 into 15 upon 28, 2 into 3 upon 28, which will be 0 plus this plus 6 upon 28, that is 21 upon 28, or 3 by 4. So this is the correct answer, 3 by 4. Option C is the correct answer to the question. Hope you understood this. Let's move to the next question. Question number 40. If the mean and variance of a binomial distribution are 4 and 4 by 3 respectively, then P at x is equal to 2 is. In a binomial distribution, we know that mean is given by NP and variance NPQ. NP is given to you as 4 in the question. So from here we can calculate, and okay, NPQ, this is given to you as 4 by 3. These two things are given. So from these two, I can easily say that Q is equal to 1 by 3. If Q is equal to 1 by 3, you will find out that P is equal to 2 by 3. Right? P and Q, they are the opposite. P is the probability of the event to happen and Q is the probability of the event not to happen. So if P is 2 by 3 and Q is 1 by 3, I can calculate using the mean, and you will see that N will come out to be 6. I got the 3 values of N, P, Q. Now, P at x is equal to 2. This will be given by 6C2P square Q raised to power 4. Which is equal to 6 factorial upon 2 factorial into 4 factorial multiplied by P is equal to 2 by 3 square 1 by 3 raised to power 4. So this will be 6 multiply 5. 6 will be cancelled with 2 in the denominator. You'll be left with the, okay, I'll do this. 6 into 5 upon 2 into 2 upon 3 into 2 upon 3 into 1 upon 3 into 1 upon 3, 1 upon 3 and 1 upon 3. This will cancel like 2. This 2 will cancel with this. And I'll be left with 20 upon. So this is 3 3s are 9. This whole multiplication will give you 243. So this is the correct answer, 20 upon 243, option A. This is the correct answer to our question. Hope you understood this. Next is question number 41. It says, let A be this. A has these coordinates, B this, C this. These are the 3 points. P is a point satisfying this particular equation. Then a point that lies on the locus of P is. Okay, so 3 points are given to you as A 5 comma minus 3, B 3 comma minus 2, C minus 1 comma 5. These are the 3 points. Now let P has the coordinates HK satisfies PA square to B PB square is equal to 3 PC square. So PA, if this is P and this is A, so PA square will be given by, you know, the distance formula. I'm using the distance formula over here. This will be given by H minus 5 square plus K plus 3 square plus 2 into H minus 3 square, 2 into K plus 2 square. This is whole equal to 3H plus 1 square plus 3K minus 5 square. Okay, let's open it. So this will be H square plus 25 minus 10H plus K square plus 9 plus 6K plus 2h square plus 18 minus 12h plus 2k square plus 4 2s are 8 plus 8k is equal to 3h square plus 3 plus 6h plus 3k square plus 75 minus 30k. Okay, so 2h square, h square, 3h square, this will cancel. K square, 2k square, 3k square. These things will cancel. And for the rest, when you will solve, you will be left with minus 10h plus 25 plus 6k plus 9 minus 12h plus 18 plus 8k plus 8 is equal to 6h plus 3 minus 30k plus 75, which on solving will give you minus 28h plus 44k minus 18 is equal to 0, which will be 14h minus 22k plus 9 is equal to 0. So seeing this, locus will be given by, this is locus will be 14x minus 22y plus 9 is equal to 0. So let's see which coordinate out of the given option satisfies the given locus. When you will try all the options, you will find out that only D is the one which is satisfying the given locus. So let's try it here. It was 14x minus 22y plus 9 is equal to 0. 14 multiplied 2 minus 22 into 37 upon 22 plus 9, 28 minus 37 plus 9. This is equal to 0. So this is the confirmation. We have option D as the answer. Hope you understood this. Let's move to the next question. Question number 42. When the coordinate axes are rotated about the origin in the positive direction through an angle of pi by 4, if the equation 49x squared plus 25y squared is equal to 1225 is transformed to this equation and the GCD of PQRT is 1, then which of the following is true? First thing, when the axes are rotated, when axes are rotated through pi by 4 about origin in positive direction, then x will be transformed to x pi by 4 plus minus y sine pi by 4, which will give you, which will make x as cos pi by 4 sine pi by 4. You know, this is 1 by root 2. X minus y will be taken common. And similarly, y will get transformed to x sine pi by 4 plus y cos pi by 4, which will simply mean that y is equal to 1 by root 2, and now x and x plus y will be taken common. So this equation now will be transformed to 49. So equation 49x square plus 25y square is equal to 1225 will, okay, I'll write it properly, will transform to 49 by 2 because x square is there, okay? X minus y square plus 25 by 2, x plus y square is equal to 1225. So solving this whole thing, when you will do all the calculations, ultimately you will get 37x square minus 24xy, 37y square is equal to 1225. Now on comparing this with px square plus qxy, ry square is equal to t. Let's do the comparison. Okay, so P will be 37, Q minus 24, R 37, T 1225. So let's check with the options. File pickup. So different options actually I tried out, but I don't have this. Like in the exams, you have to be very quick. And the instinct says me that if I will go with the third one, this one, T plus Q plus R minus 15 whole square will be equal to T. Because in this case, this is where the practice of mathematics plays a role. Here you need to have a practice of mathematics so that instead of doing all the four options and then doing the calculations, you can easily find out that C is probably the answer. So I will first of all try the C option. If it doesn't work, I'll try the rest ones. Okay. So it was P plus Q plus R minus 15 square, which is 13 minus 24 plus this whole square. This will give you ultimately solving 35 square, which is 1225. So that means this option C was my correct guess. This is satisfying exactly the given equation. Okay, so option C is the correct answer. Hope you understood this. Let's move to the next question, number 43. It says, let the slope of a diameter AC of a circle of radius 25 units be 3 by 4. If 3, 2 is the center of the circle, A x1, y1 and C x2, y2, then x1, x2 upon y1, y2 is equal to what? So let's do one thing. Let's make the figure first. This is the circle and this is the diameter, AC. Slope of the diameter of the AC of the circle, 25 radius units. So this is 25 and the center is given as 3, 2. What else? Slope of the diameter is given to be 3 by 4. So slope of AC is 3 by 4. These are few of the things which are given to you. Also, that means if I'm taking this as O, slope of AO will be same, right? 3 by 4. Okay. So if I take this point as x1, y1 and C as I'm given this in the question as x2, y2, then x1 plus x2, the half of it is equal to 3, which gives you x1 plus x2 is equal to 6. Here I use the midpoint formula, section formula. Midpoint section formula over here, right? Similarly, y1 plus y2, half of it is equal to 2, which gives you y1 plus y2 is equal to 4. Right? Hope you got this. Next, let's do this. y2 minus y1 upon x2 minus x1. This is given to us as 3 by 4. Why? This actually represents the slope of the line. So from here, you have y2 minus y1 is equal to 3 x2 minus x1. Now you're given AC, AO is 25, which means the diameter is AC is equal to 25 into 2, 50. Right? I know the coordinates of AC. A is x1, y1, C is x2, y2. So applying the section formula, you will have x2 minus x1 square, y2 minus y1 square is equal to 50. Let's do the squaring. On both the sides, you will have x2 minus x1 square, y2 minus y1 square is equal to 2500. Okay, so one thing we had y2 minus y1, like I will put this, I'll name it as number 1. I'll put it over here. Okay. So you will have x2 minus x1 square plus 9. Here was 3 by 4. Okay. So 9 upon 16 x2 minus x1 square is equal to 2500. So let's do this further. You will have this 25 upon 16 x2 minus x1 square is equal to 2500. This will cancel at 100. X2 minus x1 square is equal to 6100. Okay. So let's get back. I got x2 minus x1 square is equal to 1600. Initially we had y2 minus y1 square was equal to 9 upon 16 x2 minus x1 square. So this is again from 1, like squaring both sides. Okay, so that means you have this as 900. y2 minus y1 square as 900. Okay, so you had x2 minus x1 as 1600, correct? This x2 minus x1 square, this actually can be written as x2 plus or x1 plus x2 square minus 4 x1 x2. This is equal to 1600. You know this x1 plus x2, we initially calculated this was equal to 6. See from here. So 6 square, which is equal to 36, minus 4 x1 x2 is equal to 1600, which will give you 4 x1 x2 is equal to minus 1564. Okay, I'll take this downwards like this. So x1 x2 will come out to be like, I'll leave it till here. X1 x2 is equal to this. Okay, let's do this will be minus 391. Okay, similarly you will calculate for y1 y2. We had y2 minus y1 square was equal to 900, which will give you y1 plus y2 whole square minus 4 y1 y2 is equal to 900. y1 plus y2 we initially calculated, that was equal to 4. So 4 square minus 4 y1 y2 is equal to 900, which will give you y1 y2 is equal to minus 884 upon 4, which is equal to minus 2 to 1. Okay, now we got both the values which we're looking for, this, and let's do the division of them. So x1 x2 y1 y2, this is equal to minus 391 upon 221 upon minus 221. So on cancelling both of this, you will get 23 upon 31 as 13 as the answer. Okay, so that means let's check with the options. I have option D as the correct answer. Hope you understood this. Let's move to the next question. Question number 44. If theta is the acute angle between these two lines, then sine theta is equal to what? Very easy question actually. So the given two lines are these two lines. Now slope of this line m1 will be minus 1 by a upon 1 by b, which is equal to this. And for this line, the slope m2 will be given by minus 1 by b upon 1 by a, which is equal to minus a upon b. So these are the two slopes. Next, tangent of theta, this is equal to m1 minus m2 upon m1 plus m2. Actually, this represents the slope. Okay. So we have the two slopes, minus b upon a plus a upon b whole divided by 1 plus 1. Because when you will multiply this minus b upon a into minus a upon b, so you will have 1 for this. So this will be a square minus b square upon 2ab mod of it. Therefore, sine theta is equal to C. This is a right angle triangle. If tangent of theta is this, that means this is a square minus b square and this is 2ab. Using the Pythagoras theorem, when you will solve, you will get the hypotenuse to be equal to a square plus b square using Pythagoras theorem. Okay. So that means sine theta will be given by modulus of perpendicular, which is a square minus b square upon a square plus b square. So this is the value for sine theta. Let's check with the options. Option D stands to be the correct answer. Hope you understood this. Let's move to the next question, number 45. If the line x minus y plus 1 is equal to 0 cuts the lines this and this, then AB is equal to what? So first thing is, let A be the point of intersection of x minus y plus 1 is equal to 0 and 2x plus 2y plus 3 is equal to 0. From here, the point of intersection, when you will solve both of them, I hope you can solve both of them. The point of intersection will come out to be minus 5 by 4 and 1 by 4. Let's solve it. I'll multiply this equation with 2. You will have 2x minus 2y plus 2 is equal to 0. 2x plus 2y plus 3 is equal to 0. You will have 3x is equal to minus 5, or x is equal to, 4x is equal to minus 5, or x is equal to minus 5 by 4. Similarly, you will calculate y will come out to be 1 by 4. Okay. And now let B be the point of intersection for the rest two lines. B be the point of intersection of x minus 1 plus 1 is equal to 0 and 3x plus 3y plus 2 is equal to 0. When you will solve both these equations simultaneously, you will get the value, the coordinates of P as minus 5 by 6 and 1 by 6. Got A and B the coordinates, right? So A was having the coordinates as minus 5 by 4, 1 by 4, and B minus 5 by 6, 1 by 6. AB will be given by root of minus 5 by 4 plus 5 by 6 square 1 by 4 minus 1 by 6 square, which will be, on solving, it will give you root of 24 will be the denominator, and minus 30 plus this, you will have minus 10 square plus 24 will be taken here, and yeah, 24 will be here, and 6 minus 4, this will be minus 6 minus 4 is 2 square, right? Actually, here is a mistake. I think this is minus 1 by 4 is this. You will solve, you will get it's minus 1 by 4 over here, and this will be plus. So you will have a 10 by 4. at this place, 20 by 24. Okay, this will give you root 2, 10 upon 24, which will be 5, 6 upon 6 root 2 as the answer. Okay, so that means we have option A as the correct answer to the question. Hope you got this. Next is question number 46. If the incenter and the circumcenter of the triangle formed by these two lines and y is equal to 3 are I and S respectively, then IS is equal to. So basically, if you want to find out IS, that means you need to have the coordinates of both I and S. Okay. Now, first of all, sides of the triangle are, let's make it over here. Let's make the diagram first. So if this is supposed to be the origin, let's take this one as the origin. Let's draw this line first. This is the line 4x plus 3y plus 7 is equal to 0. And let's draw the second line, that is x is equal to 2. X is equal to 2 will be here somewhere. This is the line x is equal to 2. Okay. Next thing, okay, when you will see this, the point of intersection, this is the line where it is hand. Yes, y is equal to 3. Where is the line y is equal to 3? It will be supposed to be here somewhere. This is the line y is equal to 3. This is your, sorry. Question number 46, it says, if the incenter and the circumcenter of the triangle formed by this line, and this line, these are the three lines which are forming a triangle, are I and S respectively, then IS is equal to. To know IS, you basically need to know the coordinates of these 2 points. If you get the coordinates, you will calculate IS easily. Okay, let's make the figure first, because in such type of questions, getting a correct graph is very important. So this is the graph. Okay. This is the origin. Let's make a line x is equal to 2. This is x is equal to 2, and this one is y is equal to 3. Okay. And 4x plus 3y is equal to 7 plus 7 is equal to 0 will be a line somewhat like this. This is the line 4x plus 3y plus 7 is equal to 0. Okay. So these are the, now what is the required triangle? If see, this is A and B and B here and C here. Okay, so this point will be somewhat, this point is equal to 2, 3, right? This one will be 0, 3. This is, of course, when you will solve, this will be minus 4, 3. And this B point is 2, this one is 2, 0. And the coordinates for B will be, if I'm putting this as this, so this will be, wait. So 8 plus 3y plus 7 is equal to 0, which will be y is equal to minus 5. Okay. Next. So we got all the coordinates over here. Next is now the sides of the triangle. First of all, let's write x is equal to 2, y is equal to 3, and 4x plus 3y plus 7 is equal to 0. Right? Now let's calculate BC. Coordinates of B and C are known to you. So using those coordinates, this will be minus 2 minus of minus 4. This will be plus 6 square, and minus 5 minus 3 square, which will be 36 plus 8 square, which is 64, which will be 100 root. That will be equal to 10. Okay. Next, AC. To calculate AC, you just need this AC is equal to, you can easily see this is equal to 6. Minus 4 and 2, this is equal to 6. AB will be equal to, here is A, here is B. So this is equal to 3 and minus 5. Distance is 8. I hope you got this, right? Here is 3, here is minus 5. The total distance is 8. Now, in center, I represents in center. I is AX1, BX2, CX3 whole divided by A plus B plus C, comma, AY1, BY2, CY3 upon this. Okay, I hope you got till here. Next, just let's fill in the values. Wait, it's stuck. Okay. So this will be, see over here, this BC was equal to A, this was equal to B, and this was equal to C. So AX1 will be 10 into 2 plus 6 into 2 plus 8 into minus 4 whole divided by 10 plus 6 plus 8, comma, 10 into 3, 6 into minus 5, 8 into 3 upon 10 plus 6 plus 8. So let's solve it. You will have 12 plus 12 minus 32. Sorry, 20 plus 12 minus 32 whole divided by 24. Comma, 30 minus 30 plus 24 upon 24, which will give you 0, 1 as the in center of the triangle. Okay. Now, you know one thing you have seen from here. Look, one thing. This 6 square plus 8 square is equal to BC square. That means it's a right angle triangle. Whereas also, you can see it from the graph itself. Now, ABC is a right angled triangle. So the midpoint of BC is the circumcenter. That's the midpoint of hypotenuse. It's the circumcenter. Right? And BC, the coordinates of BC were, we knew the coordinates, right? Here is 2, minus 5 and minus 4, 3. Minus 4, 3. So the midpoint will be given by minus 4 upon 2 minus 5 plus 3 upon 2, which will be equal to minus 1, minus 1. So this is the circumcenter. Okay, we got both the coordinates. This is given by S. We got I as 0, 1 and S as minus 1, minus 1. IS will be given by root of 0 plus 1 square, 1 plus 1 square, which is equal to 1 plus 2 square, that's 4. That is equal to root 5. So here is the answer to our question, option B. Hope you understood this question. Now I'll explain this question once again. First of all, you have to make the triangle using the graph. 3 equations are given to you. X is equal to 2, y x plus 4x plus 3y plus 7 is equal to 0 and y is equal to 3. So using these 3 equations, you can find out BC, AC and AB. Right? We are done with that. So after that, I can easily find out the incenter using this formula. You know this. And circumcenter is given by the midpoint of the hypotenuse because ABC is a right angle triangle. I got the coordinates of I got the coordinates of S. I can easily find out IS. Okay, right? So that's it. I hope you got this question. Root 5 is the answer. Let's move to the next question, number 47. It says ax square minus 4xy minus 2y square is equal to 0 represents a pair of lines. If theta is equal to 0 is the angle between these lines and cos theta is equal to 1 by 5. And the possible values of A and A1 and A2, where A1 is less than A2, then A1 plus 3A2 is given by. First of all, equation given is ax square minus 4xy minus 2y square is equal to 0 represents pair of lines. Right? Also, you know, here is given cos theta is 1 by 5. So if cos theta is 1 by 5, you can see cos theta is 1 by 5. So this is 1, this is 5. You can calculate the value for this and you will find out that tan theta comes out to be 2 root 6. Okay. Therefore, also you know this, tangent of theta is equal to 2 root of h square minus ab upon a plus b. 2 root 6 is equal to 2. Here the h is this half of 4, which will be half of 4 is 2 and 2 square is 4 minus b is equal to 2 minus b will be equal to minus 2 and a will be left as such, whole divided by a minus 2. See, b is the coordinate, b is equal to minus 2. From here, h is equal to minus 4 by 2. That is equal to minus 2 again. Okay. So, you will first, these 2 and 2 will get cancelled. Root 6, 4 plus 4a. 2a upon a minus 2. Now let's do the squaring on both the sides. You will have 6 is equal to 4 plus 2a upon a minus 2 square, which will give you 6a minus 2 square is equal to 4 plus 2a. 6a square plus 4 minus 4a is equal to 4 plus 2a. 6a square plus 24 minus 24a is equal to 4 plus 2a. 6a square minus 26 plus 20 is equal to 0. 3a square minus 13a plus 10 is equal to 0. Now, let's do the splitting the middle term. On doing that, you will find the two factors to be 3a minus 10 and a minus 1 is equal to 0, which will give you the value of a can be equal to 1 or 10 by 3. These are the two possible values of a. So you are given two things, that a2 is greater than a1. So that means a1 will be equal to 1 and a2 will be equal to 10 upon 3. What do we have to find out? a1 plus 3a2. a1 plus 3a2. 1 plus 3 into 10 by 3. This will be equal to 11. So that means option A is the correct answer to our question. Hope you got that. Next is question number 48. Let L1, L2 be the lines represented by the equation this, and L3, L4 be the two lines passing through the point. Wait, my pen is stuck. Okay. So I'll repeat the question. Let L1, L2 be the lines represented by this equation, and tree L4 with the two lines passing through the point 4 by 3 such that L3 and L4 are perpendicular to L1 and L2 respectively. If the combined equation of L3 and L4 is given by this, then AF plus BG plus CH is equal to what? All right. So lines represented by 4x square minus 5xy plus 3y square is equal to 0 are L1 and L2. So dividing both the sides by x square, you will get 3y upon x whole square minus 5y upon x plus 4 is equal to 0. You know, y upon x actually represents the slope. So this can be written as 3m square minus 5m plus 4 is equal to 0. Okay, so one thing that means if this is a quadratic equation actually where the two roots or the two slopes m1 plus m2, the sum of the two will be given by minus of minus 5 upon 3, which is 5 upon 3, and the product will be given by 4 upon 3. Right? So we got these two things. I can write down 1 plus m1 upon 1 plus m2 is equal to m1 m2 m1 plus m2. This is equal to 5 upon 3 and this is equal to 4 upon 3, which will give you 5 upon 4 only. Now let the slope of the line L1 be m1. Let slope of line L1 be m1 and L2 be m2. Next is L3 is perpendicular to L1. Here also, okay, I'll write it here. L3 is perpendicular to L1, which gives you slope of L3 is equal to minus 1 upon M1. Also, L4 is perpendicular to L2, which gives you slope of L4 is minus 1 upon M2. Now let the equation of L3, let the equation of line L3, you know, the general formula is y is equal to mx plus c. So y is equal to m in this case is minus 1 upon m1 x plus c1. Since it passes, in the question it is given that it passes through 4, 3. Since it passes through 4, 3, so this will give you 3 is equal to minus 4 upon m1 plus c1, or c1 is equal to 3 plus 4 upon m1. L3 line will be given by y is equal to minus 1 upon mx, 1 upon m1 into x plus 3 plus 4 upon m1. I hope you're getting this. So y plus x upon m1 minus 3 plus 4 upon m1 is equal to 0. So this is for the equation for the line L3. Similarly, for L4, you will do all these things again. And for the line L4, you will find out that y is equal to minus x upon m2 plus c2. Again, it passes through 3, 4, 4, 3. It passes through 4, 3. So this will be 3 minus 4 upon m2 plus c2, which will give you c2 is equal to 3 plus this, right? So that means L4 will be given by line L4 will be given by y is equal to minus x upon m2 plus 3 plus 4 upon m2. This will give you 5 plus x upon m2 minus 3 plus 4 upon m2 is equal to 0. Now let's make the combined equation of L3 and L4. For that, multiply them. Y plus x upon m1 minus 3 plus 4 upon m1. Y plus x upon m2. This is equal to 0. Now you have to do all the next steps very patiently and with great care, because very high probability of making mistakes over here. So this will be y square plus xy upon m2 minus y 3 plus 4 upon m2 plus xy upon m1 x square m1 m2 x upon m1 3 plus 4 upon m2 minus y 3 plus 4 upon m1 minus x upon m2 3 plus 4 upon m1. This is multiplied with, I'm writing it over here, this is in multiplication with 3 plus 4 upon m2 is equal to 0. Okay, let's solve it further. Y square plus x square upon m1 m2 xy 1 upon m1 1 upon m2 minus x 8 upon m1 m2 plus 3 1 upon m1 1 upon m2 minus y 6 plus 4 1 upon m1 1 upon m2 plus 9 plus 12 1 upon m1 plus 1 upon m2 16 upon m1 m2 is equal to 0, which on solving further will give you y square plus 5xy upon 4 plus 3 upon 4x square minus 6 plus 3 into 5 upon 4 minus y 6 plus 5 into 5 upon 4 plus 9 plus 12 multiply 5 upon 4 plus 6 into 3 by 4 is equal to 0, which will give you y square plus 5 by 4 xy plus 3 by 4 x square 39 by 4 x 11y 36 is equal to 0, which will on further calculation give you 4y square, like multiplying both sides by 4. This will be 5xy. A minute. Okay. Okay. Plus 5xy plus 3. Actually, my pen is stuck. Give me a minute. Plus 3x square minus 39x minus 44y plus 144 is equal to 0. On comparing this with ax square 2h xy by square 2gx 2fy plus c is equal to 0, like comparing both of them, you will get A is equal to 4, H is equal to 5 by 2, B is equal to 3, G is minus 39 by 4, F is equal to minus 22, and C 144. Okay, so what we had to find out was AF plus BG plus CH, which is equal to AF is minus 88, BG is minus 117 upon 2 plus 360, which on calculation will give you 2135. So such a long question it was actually, and we have the correct option. It is not listed over here, none of the above. Option D. The correct answer is 2135. Hope you got this. Let's move to the next question, number 49. The equation x square minus y square plus ax plus b is equal to 0 represents a pair of lines for the ordered pair this. Then ordered pair is given by what? Okay, so the given equation is x square minus y square plus ax plus b is equal to 0. On comparing this with the general equation, which is ax square 2hxy b y square 2gx 2fy plus c is equal to 0, I'll get a is 1, h is 0, b is minus 1, g is a by 2, f is 0, and c is equal to p. If it represents a pair of straight lines, then it represents if it represents a pair of straight lines, then d is equal to 0, which means a b c plus 2 f g h minus a x square minus b g square minus c h square is equal to 0. So let's fill in the values only now. This will be minus b plus 0 minus 0. Wait. Okay, b minus b plus 0 minus 0 plus a square by 4 minus 0 is equal to 0, which will give you a square is equal to 4b. A square is equal to 4b. So from the given options, a square is equal to 4b. Let's check which one satisfies. When you will see a square is equal to 4b, looking at all the options, only D will satisfy this equation. So we have option D as the answer to this question. Hope you got this. See, a square, which is equal to 36, is equal to 4 into 9. That means this is the one ordered pair which is satisfying the equation. Hope you understood this. Let's move to the next question, number 50. A circle passes through the points this and this. If its center lies on this line, then its radius is equal to what? Let's make the figure for it. So this is the circle, and it passes through 1, 2. Let's say it's over here, 1, 2, and this one, this is the point A, and this will be the point B with coordinates as 3, 4. And its center lies on the last line. So here is the center. It lies on the line x minus y plus 3 is equal to 0. Okay. Okay, fine. and its radius is equal to, okay, fine, you have to find out the radius of it. That means you have to find out OA or OB. First thing, circle passes through 1, 2 and 3, 4. If its center lies on this line, center lies on x minus y plus 3 is equal to 0. And one more thing, if I draw perpendicular from here, slope of AB will be given by 4 minus 2 upon 3 minus 1, which will be equal to 1. And this one line AB is actually perpendicular to this line, which is passing through the center of the circle. Slope of the perpendicular line to AB, perpendicular line to AB will be equal to minus 1. Now midpoint of AB. This is equal to 3 plus 1 upon 2, 4 plus 2 upon 2, which will be equal to 2, 3. Now equation of the line perpendicular to AB and passing through the midpoint of the AB. Equation of line perpendicular to AB and passing through the midpoint of AB. It's given by y minus 3 is equal to minus 1, x minus 2, which will be x plus 5 is equal to x plus y is equal to 5. Also, the center lies on line x minus y is equal to minus 3. So, this is number 2. Point of intersection of equation 1 and 2 will give you the center. Okay, so let's go for this point of intersection. We have the two lines, x plus 5 is equal, y is equal to 5, x minus y is equal to minus 3. So 2x is equal to 2, x will be 1, and at x is equal to 1, you will calculate y will be 4. So you have the center as 1, 4. So radius will be given by AO. This was the center, which was O. A point was given to you initially as 1, 2. So AO will be given by root of 1 minus 1 square, 4 minus 2 square, which is equal to 0 square plus 2 square, that is equal to 2. Okay. So this is the radius of the circle we were looking for. Option D is the correct answer. Hope you got that. Next is question number 51. A line drawn through the point A 5, 7 cuts the circle x squared plus y squared minus 36 is equal to 0 at the points P and Q. Then you have to find out the product of AP and AQ. Okay, let's make the circle first. Right? So it is said the line drawn through the point A 5, 7. So there is any point A. A line is drawn which cuts a circle. The equation of the circle is given by this at P and Q. Okay. So this is point P and this is point Q. This is the center of the circle. So looking at the equation of the circle, which is given by x squared plus y squared minus 36 is equal to 0. I have two things. Center is 0, 0 and radius is 6. Okay. All right. So this is the given equation of the circle. This is P and this is Q. All right. We are done with everything. Okay. So now, if I draw another line from here, it passes through the tangent. I'm making a tangent at point D from the point A to the given circle. So AP into AQ will be equal to AT square. This is by the tangent secant theorem, which states the square of tangent segment is equal to product of length of secant tangent and its external secant segment. Okay, so according to that, AP into AQ is equal to AT square. And what is AT? AT is actually the length of the tangent over here, which is given by root of x1 square plus y1 square minus 36. So the coordinates of A are given to be 5, 7, which gives you 5 square plus 7 square minus 36, 25, 49 minus 36, which will give you root of 38. So that means AP into AQ is equal to root of 38 square, which is equal to 38. So we have option C as the correct answer. Hope you got this. Let's move to the next question. Question number 52. Let P be any point on this circle with CX as its center. AB be the chord of contact of P with respect to this circle. Then the locus of the circumcenter of the triangle CAB is. Let's make the figure first. So that means we are having two circles over here. This and this. Okay. So if I look at this one, what is the center of this circle? This is minus 1, 0, and even this is minus 1, 0. Both are having the same center. That means this is their common center, 1, 0. Next, it is said that let AB be the chord of contact of P. Okay, so I'm saying this is AB. This is the chord of contact of P with respect to this circle. So according to the question, this is the figure. If this is P, AB, this is something like. Okay. Yeah. So let this point be C. All right, we have made the figure now. So now given equation of the circle is x square plus y square minus 2x minus 1 is equal to 0. This one is having the center at 1, 0. So minus half the coefficient of x minus half the coefficient of y. Coefficient of y is missing. So this is 1, 0. So also from here you can calculate the radius. It is given by root 2. I hope you know the formula for the radius. You know the formula for the radius is given by root of g square plus f square minus c. So here the g is got to be minus 1, which is half the coefficient of x. Minus 2 divided by 2 will give you minus 1. Half the coefficient of y is f, which is 0, minus of minus 1. C is minus 1 in this case. This will give you root 2. So therefore, the radius comes out to be root 2. Okay. Hope you got this thing. Now, next is you got this equation, we got the center, we got the radius. Now, let the coordinates of P be given by. Let coordinates of PB 1 plus root 2 cos theta root 2 sine theta. Now the given equation of another circle, second circle was x squared plus y squared minus 2x is equal to 0. Now this one has the center as 1 comma 0 and radius, using the same formula, radius you will calculate and it will come out to be 1. Now the two given circles, they are concentric. That means they are having the same center. So let the circumcenter of, okay, let the circumcenter of CAB be given by the coordinates h comma k. Now circumcenter of CAB lies on the midpoint of PC. CAB, the circumcenter, lies on the midpoint of PC. Circumcenter of triangle CAB lies on the midpoint of PC, right? Sorry, this is not the point, not this one, okay? Now, h will be given by 1 plus root 2 cos theta plus 1 upon 2 and k will be given by root 2 sine theta plus 0 upon 2, which will give you cos theta. You will solve it and you will get cos theta is equal to 2h minus 2 upon root 2 and sine theta will be given by 2k upon root 2. We know one thing, cos square theta plus sine square theta. This is the general identity. Sine square theta is equal to 1. So let's do squaring both of them and adding them. You will have 2h minus 2 upon root 2 whole square plus 2k upon root 2 whole square is equal to 1. Let's take 2 common from the numerator and cancel out. You will have root 2 h minus 1 whole square plus root 2k whole square is equal to 1, which will give you 2 into h square plus 1 minus 2h plus 2k square is equal to 1, which will give you 2h square plus 2k square minus 4h plus 1 is equal to 0. Now the locus of the circumcenter will be given by the locus of circumcenter is given by 2x square plus 2y square minus 4x plus 1 is equal to 0. Let's check with the options. 2x square plus 2y square minus 4x plus 1. We have option A as the correct answer to this question. Hope you understood this. Let's move to the next question then. Question number 53. If a circle C passing through 4, 0 touches the circle this externally at the points 1, minus 1, then the radius of C is given by what? Okay, so one thing, if the circle C passing through this touches another circle which is given by this equation. We have two circles over here according to the question. Let's make the two circles. So a circle which is passing through 4, 0. Let's make this circle which is passing through a point 4, 0. Touches another circle, x square plus y square plus 4x minus 6y minus 12 is equal to 0. Now, what is the center of this circle? If you look at this, the center of the circle will be masked minus half the coefficient of x minus half the coefficient of y, which will be given by minus 2, 3. Okay. And this is the center. Have some coordinates with you. So, center will be given somewhere around minus 2, 3 over here. If I say, for your convenience, I have paused the video and drawn the whole figure now. Now let's understand this. What is this? I have taken the coordinate axis. You know, this is x-axis and y-axis. I don't think I need to tell you about this. These are the two circles, C and C2. This C circle is represented over here, and this equation is for this C2 circle. According to the equation, x squared plus y squared, let's write out x squared plus y squared plus 4x minus 6y minus 12 is equal to 0. You know the center is given by minus g minus f. G is half the coefficient of x and f is half the coefficient of y. So this will be minus 2 comma 3. This is the center. And radius, you know, we discussed the formula in the last question itself, root of g squared plus f squared minus c. According to that, root of g square is 4 plus 9 minus of minus 12 will give you plus, which will be 25 root, that is equal to 5. So I have the radius as 5 units for the circle C2 and the radius as root of, simplify, not root 5, simplify. Now tangent at M to the circle, both the circles, the tangent is at M. Tangent at M, which is the point 1 comma minus 1. This is 1 comma minus 1. I have written this wrong. Okay, 1 comma minus 1 to the circle C2 or C1, like both the circles to the circle C is given by x into x1 y1 plus 4x plus x1 upon 2 minus 6y plus y1 upon 2 minus 12 is equal to 0, which will give you on solving x minus y plus 2x plus 1 minus 3y1 minus 12 is equal to 0, right? Because x1 was minus 1 and this y1 was x1 was 1 and y1 was minus 1. So on solving, you will get x minus y plus 2x plus 1 minus 3y minus 1 minus 12 is equal to 0, which on solving will give you 3x minus 4y minus 7 is equal to 0. So equation of the circle. So equation of the circle C touching this line, the line 3x minus 4y minus 7 is equal to 0 at the given point 1 comma 1 is given by x minus 1 square plus y plus 1 square plus lambda of 3x minus 4y minus 7 is equal to 0. Since it passes through 4 comma 0, it passes through, this circle C passes through 4 comma 0, it's given in the question. Therefore, you can write down 4 minus 1 square plus 0 plus 1 square plus lambda 12 minus 0 minus 7 is equal to 0, which will be 9 plus 1 plus 5 lambda is equal to 0, or lambda will be equal to minus 2. So now the equation of the circle becomes, now C equation of circle C becomes equivalent to, which was actually x minus 1 square plus y minus y plus 1 square plus lambda we calculated minus 2, 3x minus 4y minus 7 is equal to 0. X square plus 1 minus 2x, y square plus 1 plus 2y minus 6x, 8y, 14 is equal to 0, which will give you x square plus y square minus 8x plus 10y plus 16 is equal to 0. This is the equation of the circle C, which you were looking for actually. So center for the circle C will be given by minus 8 half, like minus 8 half. This is 4 and this will be minus 5. This is the center, and radius will be root of 4 square plus minus 5 square minus 16, which will be equal to 5 square or 5. So we have the radius as 5 and center as 4 comma minus 5. What we were looking for in the question was radius of C. Radius of C we calculated, this is 5. So we have option D as the answer to this question. Hope you understood this whole thing, right? Let's move to the next question, 54. If the circle C1 is given by this, C2 is given by this, have n common tangents, and the length of the tangent drawn from the center of the similitude to the circle C2 is L, then L by n square is given by. So now you are given that the first circle C1 is given by x square plus y square plus 2x plus 4y minus 20 is equal to 0. This one is having the center O1. O1 I'm representing the center for this circle, will be given by minus half the coefficient of x, which is minus 1, minus half the coefficient of y will be minus 2. This is the center, and the radius R1 will be given by root of 1 minus 1 square plus minus 2 square minus of minus 20, which will be plus 20, which will be 1 plus 4 plus 20, that will be 5. Right, this is for the circle C1, and let's go for the circle C2. The equation is given by x square plus y square 6x minus 8y plus 9 is equal to 0. Now here the center O2, I'm representing the center for the circle. It will be given by minus 3 and 4, and R2 will be given by root of minus 3 square 4 square minus 9, which will be 9 plus 16 minus 9, that will be 4. So R2 is 4, R1 is 5. Got all these things? Next is here, if I'm looking at R1 and R2, R1 plus R2, this is equal to 9. R1 minus R2, mod of it will be equal to 1. C1, C2, this will be given by C1, C2 is given by C1 is equivalent to, which is actually O1 minus 1. I can write down O1 over here. This is minus 1 minus 2, and O2 is given by minus 3 comma 4. So C1, C2 is actually O1, O2 in this case. I can say O1, O2 will be given by root of minus 3 plus 1 square plus 4 plus 2 square, which is equal to 4 plus 36, which is equal to root 40, which is equal to 6 point something, right? So that simply means that R1 plus R2 is greater than O1, O2 is greater than R1 minus R2. This simply means that these two circles, they are intersecting at 2 points and they are having 2 tangents. Therefore, these two circles are intersecting at 2 points. 2 points, and therefore we have 2 tangents. N is equal to 2 in this case. N were the number of tangents, N came out to be 2 in this case. Now let's make the figure for this, because the sum will be very much understandable if you get the correct figure. Okay. So these two circles, of course, one is having the radius as 5 and another is having the radius as 6. Let's make these two circles. This is the first one. The center of the circle is given by minus 1, minus 2. This is O1. And the second one, they are intersecting at 2 points. This has got to be a smaller one. So this is a smaller one. So here you are having O2 as the center, and the center is given by minus comma minus 3 comma minus 4. Right, here the radius is 5 and here the radius is 4. I think we are done with the figure. So this is the circle C1 and this is the circle C2. Now, yes, of course, the 2 tangents we have to draw. So let this be the point. Let this be the point of the stimulate. Give me a minute. Okay. So similitude point is P. If I'm taking this to be the point P, let's draw the two tangents. This is the point P, and one tangent from here also, right? So, okay, so something like this. So this is the P is the point of similitude, similitude for the circle C2. Now, P divides O1 and O2. P divides O1 and O2 in the ratio of 5:4 externally. Therefore, P's coordinates will be given by -3 multiply 5 minus of -1 multiply 4 whole divided by 5 minus 4. 4 multiply 5 minus 4 multiply -2 whole divided by 5 minus 4. So the P coordinates will be given by -15 plus 4, which is -11 upon 1, and 20 plus 8 is 28 upon 1. So P is having the coordinates -11, 28. Now let L be the length of the tangent from P to C2. L be the length of the tangent from P to C2. So L will be given by root of P's coordinates. We got C2. We know C2 is actually O2, right? So we know the coordinates of both the points. Therefore, it will be given by -11 plus 3 whole square plus 28 minus 4 whole square minus 4 square, which will be equal to -8 square, which is 64, 24 square, which is equal to 576 minus 16. This will be equal to 624 root or 4 root of 39. So we got the value of L, right? And we got the value of N also. What we had to find out? L upon N square. So we got both the values. Easy to do now. L upon N square will be given by 4 upon root 39. N was equal to 2. So these two will cancel and you will have root 39 as the answer. Let's check with the options. We have option B as the correct answer to this problem. Hope you understood this. Let's move to the next question. Question number 55. If the common chord of the circles this and this is the diameter of the circle S is equal to 0, then the abscissa of the circle S is equal to 0 is. So these are the two circles. Let's make the figure first. These are the two circles, 1 and 2. This is the circle C1. Let the center of the circle be C1 only, and this is C2. So this is the first one. C1 is given by x square plus y square plus 4y is equal to 0. From here, you know the center. It is 0, comma -2. And the radius will be given by, this is 0 square, this plus 0, which will be 2 only. Okay. Second circle, x square plus y square minus 4x minus 5 is equal to 0. Here the center will be given by not minus. Here the center is equal to 2, comma 0. And the radius in this case will be 2 square, which is 4 plus 5, that is equal to 3. So C2 is given by 2, comma 0. C1 is given by 0, comma -2. And the radius in this case is, this radius is 2 and this radius is 3. Okay. So we have everything now. Now the common chord between them is given by this. This is the common chord between them. Right? This is a circle actually. Okay, fine. So common chord of C1 and C2 is C1 minus C2 is equal to 0. What was C1? X square plus Y square plus 4Y minus X square minus Y square plus 4X plus 5 is equal to 0. These will cancel out and you will have 4X plus 4Y plus 5 is equal to 0. Now let M be the point of intersection of the chord and the line joining the center C1 and C2. So let this be the point M. Let M be the point of intersection of common chord and line joining C1 and C2. Also, let M divide C1 and C2 in the ratio lambda is to 1 internally. Therefore, M will be given by, you know the coordinates of C1 and C2, right? C1 coordinates are known to you, C2 coordinates are known to you. So internally, M will be equal to, so they are dividing, M divides C1 and C2 in lambda is to 1 ratio internally. So M will be given by 2 lambda upon lambda plus 1 minus 2 upon lambda plus 1. Now, M lies on the common chord, right? So this point lies on this particular line because this was the equation of the common chord, 4x plus 4y plus 5 is equal to 0. So using equation of common chord, which is 4x 4y plus 5 is equal to 0. So 4 into 2 lambda upon lambda plus 1, 4 into minus 2 upon lambda plus 1 plus 5 is equal to 0, which will be, this will be 8 lambda minus 8 upon lambda plus 1 plus 5 is equal to 0. Lambda 8 minus this plus 5 lambda plus 5 is equal to 0. 13 lambda minus 3. So lambda will be 3 upon 13. Also now, M is the center of the circle whose diameter is the common chord of both the circles. M is also the center of the circle whose diameter is common chord of both the circles. So abscissa, which was this one. See, the abscissa was this. So we got the lambda, right? So abscissa of M, which is given by 2 lambda upon lambda plus 1, 2 into 3 upon 13, whole divided by 3 upon 13 plus 1, 6 upon 13, multiply by 13 upon 16. So 3 upon 8. This is the abscissa of the point M, right? That means we have option B as the correct answer to the question. Hope you understood this question. Next is question number 56. It says if y square is equal to 16x is the given parabola, then the point of intersection of the focal chord through the point 2, 2 and the double ordinate of length 24 is. Let's make the figure. Let's make the parabola. This is y square is equal to 16x. which resembles 4, y squared is equal to 4ax. Here, a will be equal to 4. Let's make the figure here. So this is the figure, right? This is the given parabola. A is equal to 4. So this is the focus, 4, 0. Then the point of intersection of the focal chord through the point 2, 2. Okay. So let's make the equation. Equation of focal chord passing through four, 0 and 2, 2. The equation will be given by y minus 0 is equal to I'm using this one, y minus y1 is equal to m into x minus 8. I'm using y minus y1 is equal to m into x minus x1, where m is the slope. And the slope will be given by 2 minus 0 upon 2 minus 4, x minus 4. Y will be equal to minus 1, x minus 4, or x plus y will be equal to 4. Okay. All right. The next thing, it's given that the double ordinate of the length 24. This is the double ordinate of the length 12. Okay. This is 12 and this is 12. All right. I think I've done everything, right? Okay. So now, first thing is let B be this point x1, 12, which lies on the parabola here. Let this be the point x1, 12. Right? So using the equation which is given, y square is equal to 16x. You have 12 square is equal to 16 into x1. So 12 into 12 upon 16 is equal to x1, which will give you 3, 4. So x1 comes out to be 9 and point B is 9, 12. Right? Now, equation of the double ordinate, of course, it's x is equal to 9. Equation of the double ordinate. So let the two ones be, if I'm taking this as 1 and this one as 2, point of intersection of both the equations, point of intersection of equation 1 and 2, x is equal to 9, y, okay. I have x plus y is equal to 4, x is equal to 9. So with that, y will be minus 5. So the point of intersection of both of these lines will be given by 9, minus 5. Okay, so this is the answer to the question. We have option B as the correct answer. Hope you understood this. Let's move to the next question. Question number 57 says, let PQ and RT be the two focal chords of this parabola. Same parabola which we have done. If P is given by this, R is given by this, then QT is equal to. Let's make the figure first to understand the problem. So this is the given parabola. It's y square is equal to 16x. Of course, we have a is equal to 4 in this case. If a is equal to 4, then, okay, let's make this. So this is the focus, which is given by 4, 0. You are given that PQ and RT are the two focal chords. So let's make that. This is P, Q, and let this be any random RT. Okay, P is given by 4, 8. And R is given by 16, 16. All right. So now P, which is 4, 8, is equivalent to 2at1 square 2at1. So here 281 is equal to 8. A is equal to 4, which gives you T1 as 1. Now, PQ is the focal chord. Then, you know, T1, T2 is equal to -1, which gives you T2 is equal to -1. We got T1, we got T2. We already know A. Okay. So, Q will be given by A T2 square 2AT2. So filling it, you will get the coordinates of Q as 4 into -1 square, comma 2 into 4 into -1, which is equal to the coordinates of Q will be given by 4, comma -8. These are the coordinates for Q. Now let's go with R. R has the coordinates as 16, comma 16, which are actually equivalent to A T3 square 2A T3. So here 2AT3 is equal to 16. A was 4, which gives you T3 is equal to 2. Now same thing. RT is the focal chord. Then T3 multiply T4 is equal to -1, which gives you T3 is equal to 2, which gives you T4 is equal to -1 by 2. Right? So the coordinates of T are given by AT4 square and 2AT4. Have to be patient because the slight mistake at any point can disturb the whole sum. So this is 2 into -1 by 2 square, 2 into 4 into -1 by 2, which will give you the T coordinates as 1 by 4. So the T will have the coordinates as, give me a minute. Okay, so this will be -1 by 2. Here was a mistake. A was 4. It was not equal to 2. A was 4. So this will be equal to 1, comma, -4. These are the coordinates for T. We know the coordinates for Q. We know the coordinates for T. And we can easily find out QT using the distance formula. So QT will be equal to root of, what is Q? 4, comma, -8. So 4 minus 3 square plus -8 plus 4 square, which is equal to 3 square, that is 9. And this, so this is equal to 5. So Q2 comes out to be 5. Option A is the correct answer. Hope you understood this. Let's move to the next question, number 58. If the eccentricity and the length of the latest rectum of an ellipse, this and this respectively, then the sum of the length of major and minor axes of the ellipse is what? So you are given the ellipse as x square upon a square, y square upon b square is equal to 1. Eccentricity is given to you √3 by 2. And the formula for the centricity is 1 upon minus b square upon a square. This is equal to √3 by 2. So let's do the squaring on both the sides. You will have 1 minus b square upon a square is equal to 3 by 4. So a square minus b square is equal to 3a square by 4. 4a square, 4b square, 3a square, which will give you a square is equal to 4b square, or b square is equal to a square by 4. Also, next we are given that the length of latest rectum is equal to 1. Length of latest rectum is equal to 1, which is 2b square upon a is equal to 1. B square we just said, a square by 4. So 2a squared by 4 into a is equal to 1, which gives you a is equal to 2. Okay. So let's see next. If a is equal to 2, what was equal to b? B square was a square by 4. That means b is equal to 1. Okay. So the sum of length of major and minor axis, you got a and b. Sum of lengths of major axis and minor axis is 2a plus 2b. A was equal to 2 and b was equal to 1, which is equal to 6. Sorry. So sorry for that. I have just erased the whole sum. Okay, so sorry for this. Actually, we got the answer, right? It was 6. So option A is the correct answer. You can rewind the video and watch the explanation of the sum again. That is there in the video. So the answer to the question is option A. Hope you understood this. Next is question number 59. The parametric equations of the ellipse whose foci are this, and eccentricity is 1 by 3 is given by what? Okay. So you are given that foci of ellipse are this and this, right? So this is, let it be F1 and this be F2. Center of the ellipse will be the midpoint of both these foci. So center of ellipse will be midpoint of F1 and F2, which is given by O minus 3 plus 9 upon 2, 0 plus 0 upon 2, which gives you O coordinates as 3, 0. Right? Also, over here, also distance between two foci is given by 2AE, right? And this is the two coordinates are given to be minus 3 and 9. Distance between, see, minus 3 and if I make this is minus 3, 0 and this is 9, 0. Right? The distance between them is, of course, 12. So that means this is equal to 12. And you are given the centricity to be equal to 1 by 3. So E is given to you as 1 by 3, which makes this 2A into 1 by 3 is equal to 12, which makes A as 18. Right? Also, you know one thing, eccentricity is given by the formula 1 minus b square upon a square. This is equal to 1 by 3. Squaring both sides, you will get a square minus b square upon a square is equal to 1 by 9, which makes 9 a square. This is, which makes 8a square is equal to 9b square. I want to find b. So b will be given, b square will be equal to 8 by 9 into a square, or b will be equal to, a we already calculated. I'll fill a over here. A is 18, right? Okay. This multiply 18 whole under the root. So 2, which will be equal to, when you will solve it, it will give you 12 root 2, right? So this is the value of b. We already calculate the value of a to be 18. And we know the center of the ellipse is at 3, 0. This is the center of the ellipse. Now let's make equation of ellipse. This is given by x minus 3 square upon a square. You know, this is the general form. This has the general form. X minus x1 upon a square, y minus y1 square upon b square, right? So this will be plus y minus 0 upon square with 12 root 2 square is equal to 1, right? So let's solve it. You will see we wanted, but the question has the parametric form, right? It is the side cross thing. So I'll equation of the ellipse in the parametric form. In the parametric form is given by x minus 3 will be a cos theta and y minus 0 will be b sin theta. A was 18, so x minus 3 is equal to 18 cos theta and y is equal to 12 root 2 sin theta. So these are the two. Okay, x can be written as 3 plus 18 cos theta and y is the this. So now let's check with the options which is the correct one. 3 plus 18, this is not the one. No, I know. So we have option B as the correct answer. Hope you understood this question. Next is question number 60. Okay, it says if x square upon this plus y square upon this is equal to 1, then you have to find out the value of k. Okay, so simple as that. Equation here, this is an equation of an ellipse. So a is given as root of this k minus 5 by 2 and b is given as root of 7 by 3 minus of k. This is the value of a and b. So that means, of course, k minus 5 by 2 is got to be greater than 0 and 7 by 3 minus k is greater than 0. Of course, for see, the k is a real number over here. So that means k is greater than 5 by 2 and here the k is less than 7 by 3. So k's value lies between k is greater than 5 by 2. So 7 by 3 greater than k greater than 5 by 2. That means k belongs to minus infinity 7 by 3 union 5 by 2 and infinity. So we have option A as the correct answer. Hope you understood this question. Let's move to the next question, number 61. If A theta 1, B theta 2 be the 2 points on this hyperbola and S be the focus of the hyperbola, so A, S, B are collinear and A cos theta is this, is equal to K cos theta minus theta 1 minus theta 2 upon this, then K is equal to. Okay. So first of all, this question is about the hyperbola. The equation of the hyperbola is x square upon a square minus y square upon b square is equal to 1. And the focus is given. Focus of this S is, focus S is given to be AE comma 0. Now A theta 1 and B theta 2 are the 2 points on the hyperbola. A theta 1, B theta 2. Be the 2 points on the hyperbola. So the equation of the chord joining these 2 points joining A theta 1 and B theta 2 is given by x upon A cos theta 1 minus theta 2 upon 2 minus y upon B sine this is equal to cos theta 1 plus theta 2 upon 2. Now it is said that A, S, B, they are collinear. So S lies on AB. Now A, S, B are collinear. So S lies on line AB, right? Therefore, AE upon A cos theta 1 minus this upon 2 is equal to cos theta 1 plus theta 2 upon 2, because the y is 0 in this case, right? Which can be written AE cos theta 1 minus this upon 2 is equal to A cos theta 1 plus theta 2 upon 2. Now let's compare it with this equation which is given over here. We'll have to swap the positions. It will be A cos theta 1 plus theta 2 upon 2 is equal to AE cos theta 1 minus theta 2 upon 2. So comparing that, now let's compare it with the given one, which was A cos theta 1 upon theta plus theta 2 upon 2. This is the given one, right? And we have to do the comparison. This is equal to K cos theta 1 minus this upon 2. So that means comparing both of them, you will say K is equal to AE, right? Or K is equal to A into E was given by 1 plus a B square upon A square. That is equal to A into A square upon B square upon A square. So this is under the root. Actually, these two will cancel and you will have root of A squared plus B squared as the answer. Okay, so we have option B as the correct answer. Hope you understood this question. Then let's move to the next question, number 62. Let A be this, B be this, C be this, D is this, with the vertices of a tetrahedron, and G be the centroid, G1 be the centroid of its face BCD, then AG1 and upon AG is given by what? All right, first is we have the 4 coordinates. The A is 1, 2, 3, 4. Sorry, not 4. It was 3 only. Minus 1, 4, 6. C is 0, minus 6, 4. And D is 1, 1, and 1. So G will be, it is given that G is its centroid. G will be given by 1 minus 1 plus 0 plus 1 upon 4. 2 plus 4 minus 6 plus 1 upon 4. 3 plus 6 plus 4 plus 1 upon 4. So G is 1 by 4, 1 by 4, 14 by 4, right? Okay. G1 be the centroid on its face BCD. So G1 will be given by, this is G. Okay. And let's go for G1. So BCD, it is minus 1 plus 0 plus 1 upon 3. 4 minus 6 plus 1 upon 3. This upon 3. So the G1 coordinates will be given by 0 minus 1 by 3, 11 by 3. So we have the coordinates for G and G1. Now, AG1 we can find out using the distance formula. It will be given by the coordinates of A are known to us, 1, 2, 3. So let's write it here. A is given by 1, 2, 3. So this will be equal to 1 minus 0, which is 1 square, plus 2 minus 1 by 3. Okay, sorry, 2 plus 1 by 3. This will be 7 by 3 square, plus 11, 3 minus 11 by 3. So this will be 2 by 3 square, which will be 1 by 3 root of 9 plus 49 plus 4, that is equal to this. This is AG1. Similarly, I'll calculate AG. This will be equal to 3 by 4 square, 7 by 4 square, 2 by 4 square, which will be, I'll take 4 common, 1 by 4 outside. So 3 square 9 plus 49 plus 4. I'll have the same thing. Yeah, this is equal to root of 62 upon 4. So simple, AG1 upon AG is equal to root of 63 upon 3, root of 63 upon 4, which will be equal to 4 by 3. So we have option B as the correct answer. Hope you understood this question, but actually this is very, very easy question. So next one is question number 63. If a line L is common to these two planes, then the direction cosines of the line L are. Okay, so first plane is given by P1 is x minus y plus z plus 2 is equal to 0. Here N1 is 1, minus 1 and 1. So second one, P2 is 2x minus plus y minus 2z plus 5 is equal to 0. So N2 is 2, 1 and minus 2. Now the vector along the line of intersection of P1 and P2, vector along the line of intersection of P1 and P2 is equal to this. Let's go for this. So this is given by I, J, K. N1 was 1 minus 1, 1. This is 2, 1 and minus 2. So on solving, you will get 2 minus 1, minus 2, minus 2, 1 plus 2. This is equal to I, 4, J, 3, K. What we had to find out in the question, then the direction cosines of L are. Okay. This is n, right? This is n vector and the modulus of it is given by 1 square, 4 square, 3 square, which is equal to 1 plus 16 plus 9, that is equal to root of 26. Now the direction cosines will be given by 1 upon root of 26, 4 upon root of 26 and this. Okay, so these are the three direction cosines. Let's check. We have option A as the answer. Hope you got that. Next is question number 64. Let the foot of the perpendicular drawn from this point to the plane this, then the perpendicular distance from the origin to the plane is. Okay. First thing you have said, let the foot of the perpendicular drawn from this point. So let's make it. There is a plane. There's a plane. Let's make the plane here. This is the plane and you have to drop a perpendicular from the point 1, 2, 3 onto the plane. Okay. So this point is minus 1, 3 and minus 2. Now direction ratios of normal to the plane will be 1 minus of minus 1, 2 minus 3, 3 minus of minus 2, which is 2 minus 1 and 5, right? This is equivalent to your ABC, let's say. Now the plane passes through -1, 3, and -2, which I am taking equivalent to x1, y1, and z1. Now, equation of the plane will be given by, wait, what do we have to find out? Okay. Equation of the plane ax minus x1, this, and z minus z1 is equal to 0. So a was equal to 2, x minus of -1, this will be +1, minus b was equal to -1. So this is, and y minus 3 plus 5z plus 2 is equal to 0, which gives you 2x plus 2 minus y plus 3, 5z plus 10 is equal to 0. So it will be 2x minus y plus 5z plus 15 is equal to 0. Next, it says, let's get back to the question. Perpendicular distance from the origin to the plane. So perpendicular distance from the origin to the plane, let's go. Perpendicular distance from origin to the plane. It will be given by mod of 0 minus 0 plus 0 plus 15 whole divided by root of 2 square plus 1 square, which is actually -1 square, so 1 square plus 5 square. This is modulus of 15 upon 4 plus 1, 5 plus 25, that is 30. So this will be, actually you'll solve it, you will get this as 15 root into 15 root upon 15 root into 2 root. So you will have under root of 15 by 2 as the answer. Let's check with the options. We have option B as the correct answer. Hope you understood this question. Next is question number 65. So we have a limit problem over here. Limit x approaching 3 minus, this whole expression is equal to what? Actually, very easy question. Let's write it down. So limit x approaching 3 minus x cube minus 3x square minus 4x plus 12 whole divided by 2x cube minus 7x square 2x plus 3. So let's factorize it. Limit x approaching 3 minus x minus 2 x square minus x minus 6 whole divided by, I'll take x minus 1 and 2x square minus 5x minus 3. Let's factorize it further. X approaching 3 minus x minus 2. When you will factorize, you will have this as x minus 3 and x plus 2 whole divided by x minus 1, 2x plus 1, and x minus 3. Now x is approaching 3 minus. So you will have, let's put the limits now. So this will be 1 multiply 5 upon 2 multiply 7. This will be 5 upon 14. So this is the answer. That means I have option C as the correct answer to the question. Hope you understood this. Question number 66, it says limit x approaching 0. This whole expression is equal to what? Let's write it down. Limit x approaching 0. So 2 raised to power 2x can be written like this. 2 raised to power x raised to power 2 minus 2 into 2 raised to power x plus 1 minus cos 2x whole divided by x square. So if I'm taking this as a and this one as b, this is, you understand this, this is a formula of a minus b whole square, which says limit x approaching 0, 2 raised to power x minus 1 whole square plus 1 minus cos 2x can be written as 2 sine square x. So this is equal to 2 sine square x whole divided by x square. Limit x approaching 0, 2 raised to power x minus 1 upon x plus 1 plus 2, limit x approaching 0 sine x upon x. You know, this thing is equal to 1. When limit x approaching 0, sine x upon x is equal to 1. And limit x approaching 0 to x minus 1 upon x is equal to natural log of 2. These are the two formulas. So this can be written as natural log 2 square plus 2 into 1, which is equal to 2 plus natural log of 2 square, which is, okay, this is option B. This is the answer to the question. Hope you got this. Next is question number 67. Fx is equal to x square minus 16 upon x minus 4 if x is greater than 4, and this is equal to 2x if x is less than equal to 4. Then you have to find out the value of this expression. Fx can be written as x square minus 16. This can be written as x plus 4, x minus 4 whole divided by x minus 4 if x is greater than 4. These two will cancel, and this is equal to 2x if x is less than equal to 4. Right. We have to find out the limits when f is approaching my 4 minus. This can be written as limit h approaching 0, f of 4 minus h minus f of 4 whole divided by minus h. So now this is of the form, this x is less than equal to 4. So I'll use 2x formula. Limit h approaching 0, 2 into 4 minus h minus 8 upon minus h. This will be 8 minus 2h minus h upon minus this. So this will give you answer as 2. Now f dash when x approaching 4 plus, this is given by limit h approaching 0, f of 4 plus h minus f of 4 whole divided by h. So this will be C. Now this is 4 plus. So I'll use up this one, x plus 4 thing. So this is equal to limit h approaching 0, limit h approaching 0, 4 plus h plus 4 minus 8 upon h. So these will cancel out and you will have h upon h, which is equal to 1. Now let's get to question. What we had to find out? This whole expression, right? We got all the values. Now just fill in up. 2 plus 1 is equal to 3. So this is the answer to our question, option C. Pretty easy question. Hope you understood this well. Next is question number 68. If fx is equal to natural log of this whole expression and x is not equal to minus 5 upon 3 or 5 upon 3, then the first derivative of the function at x is equal to 1 is. All right. So let's write down. You are given fx is equal to log e raised to power 2x, 3x plus 5, 5 minus 3x, whole raised to power 2 by 3. X is not equal to, do remember this thing, x is not equal to minus 5 by 3 or 5 by 3. All right. Now let's split it up. This can be written as log e raised to power 2x plus log 3x plus 5 minus 3x raised to power 2 by 3. So this is equal to 2x log e to the base e plus 2 by 3. Now I'll split it up again. Log e 3x plus 5 minus log 5 minus 3x. This is the function. Now let's find out the first derivative of it. So df upon dx is equal to, this is equal to 1. 2x log e E is equal to 1. This is actually equal to 2x, and the derivative of 2x is equal to 2 only. Plus 2 by 3. So 3x plus 5, the derivative is given by, first of all, 1 by 3x plus 5 multiplied by 3 minus 1 by 5 minus 3x multiplied by minus 3. Is the first derivative of the function. This can be, I'll write it properly. So 2 plus 2 by 3, 3 upon 3x plus 5 plus 3 upon this. Now, we had to find out the derivative of the function at x is equal to 1. So let's fill in x is equal to 1. You will get 2 plus 2 by 3, 3 upon 8 plus 3 upon 2. So this is 2 plus 2 by 3, 3 plus 12 upon 8, which is 15 by 8. So 2 plus 2 by 3 into 15 by 8, 4, 5. So 2 plus 5 by 4. And this is equal to 13 by 4. So this is the answer to our question, 13 by 4, option D. Hope you understood this. Next is question number 69. If x is equal to cosecant theta minus sine theta and y is equal to this whole thing, then second derivative of y is equal to this. Now, where k belongs to the complex numbers, then 10 plus k minus g into 2022 is equal to what? You are given x is equal to cosecant theta minus sine theta. Let's squaring both the sides. You will have x square is equal to cosecant theta minus sine theta whole square, which will give you cosecant square. Actually, okay, square theta plus sine square theta minus 2 cosecant theta into sine theta, which is equal to 2 only, right? Plus sine theta, sine square theta minus 2. Now, adding 4 on both the sides, you will get x square plus 4 is equal to cosecant theta plus sine theta whole square. Right? Now, this is for the x. I'll solve for the y as well now. Now, let's go for y. Y is given to you as cosecant raised to power 2022. Actually, the sum is not tough, but the bigger terms like powers 2022 will make it look a bit tough. So you have to solve this type of sums very patiently so that you don't make any mistake, because any mistake at any point of time in mathematics will disturb the whole sum. Okay. Okay. So why was this? Minus sine raised to power 2022 into theta. Theta. Similarly, if you will follow the same procedure which I have followed in the first case, you will get y square plus 4 is equal to cosecant raised to power 2022 theta plus sine raised to power 2022 theta whole square. Right? Now, this is for the y. Let's calculate, find out the first derivative of y with respect to theta. Let's go for this. This will be 2022 into cosecant 2 raised to power 2022 theta into the derivative of cosecant theta. Derivative of cosecant theta is minus cosec theta into cot theta. And for the sine, this is 2022 into sine 2 raised to power 2021 theta. Sine theta derivative is cos theta. Right? So dy by d theta can be written as, I'll take 2022 common from here, minus 2022 common, and cot. See, I'm opening this cot in as cos upon sine. Okay, so I'll take cos theta also common from here. I'll be left with cosecant raised to power 2022 theta upon sine theta plus sine 2021 theta, right? So dy by d theta is equal to minus 2022 cotangent of theta into cosec 2022 theta plus sine 2022 theta, right? Because I have taken this like denominator, and this cos theta upon sine theta will behave as cot theta. I hope you got this step, right? So next is I found dy by dx. Now, sorry, dy by d theta. Next is the turn for finding out dx by d theta. So x was given to you as cosec minus sine theta. So let's find out the first derivative, dx by d theta. This is equal to minus cosec theta cot theta minus cos theta. This is equal to, I'll take the minus cot theta outside. So this will be cosec theta plus sine theta over here, right? Now I have the two things, I will divide them. Dividing 1 by 2. Okay, you will get dy by dx is equal to 2022 cosec 2022 theta sine this theta whole divided by cosec plus sine. Right, now let's find out. Okay, in the question it was not the second derivative, sorry, I said the second derivative over here. It is actually the square of the first derivative. Now let's do the squaring on both the sides. So dy by dx whole square is actually equal to 2022 whole square. And see, cosec cosec raised to power 2022 theta plus sine raised to power 22 theta. This is actually equal to y square plus 4. We solved it over here, right? So I will put it y square plus 4 whole divided by, similarly this is equal to x square plus 4, right? So next is, this is dy by dx is equal to, it's given that this is equal to whole this thing. Let's write it down. Wait. Okay. Okay, so this is given to you as k into y square plus 4 whole divided by g of x is equal to this. This was in the brackets. So y square plus 4 whole divided by x square plus 4. So looking like comparing both of them, you get k is equal to this and gx is equal to x square plus 4. What we had to find out in the question was 10 plus k minus g of 2022. So to solve was 10 plus k minus g of 2022, which is equal to 10 plus k was this minus g was 2022 whole square plus 4. So these two will cancel out and you will have 10 minus 4, which is equal to 6. This is the answer to the question. Option B. Hope you understood the question. Let's move to the next question then. Question number 70. It says the area of the triangle formed by the tangent and the normal drawn to the curve y square is equal to 4x at 1, 2 with y-axis is what? Let's make the figure first. So this is the one. The area of the triangle formed by the tangent and normal to this curve. So this curve y square is equal to 4x. This is given by this. Wait, it will actually just touch it. Okay. This is origin. This point actually represents the origin. So, okay, the area of the triangle formed by the tangent and the normal to the curve y square is equal to 4x. Let's make it. Question number 70. The area of the triangle formed by the tangent and the normal drawn to this curve at 1, 2 coordinate with the x-axis is. Okay, so first thing, let's make the curve. This is y square is equal to 4x. This is given by this. Okay, somewhat of this type. Actually, it has to be more curved on the lower end, so it's okay. All right. So next, there is a tangent and normal drawn to this curve at 1, 2. So this is the point 1, 2. I'm taking this as the origin. This is the origin point, and this is the point P. There is a tangent which is drawn at this point. Let's make the tangent. All right. And also a normal with the x-axis. So actually it will go beyond. So somewhat like this it will be. Okay. This is the normal. This is the point N I'm taking. And let's name this one as P. And this is y square is equal to 4x. This is the point P. All right. So we have labeled the whole diagram. Now, the question is the area formed by the triangle formed by the tangent, which is this line, normal, and the y-axis. So actually, you have to find out the area of this shaded portion. Hope you understood the problem, right? Now, the given problem, the given curve is y square is equal to 4x. Let's find out the derivative of it. So this is 2y into dy by dx is equal to 4, which gives you dy by dx is equal to 2 upon y. Now, at the point 1, 2, the derivative, actually this means the slope. The derivative will be equal to 2 by 2, which is equal to 1, right? Now, the equation of the tangent will be given by equation of tangent y minus 2, 1, x minus 1, which gives you y is equal to x plus 1, right? That means the point T will be given by 0, 1. If I'm taking x is equal to 0, y will be 1. So that point T, which is this one, this point, this is 0, 1. Okay. Now, slope of the normal. Slope of normal will be equal to, since the normal and the tangent, they are perpendicular to each other, right? This is normal and this is tangent, and they are normal to each other. So that means the product of their slopes will be equal to -1. And slope of the tangent is equal to -1. Therefore, the slope of the normal will be equal to, the slope of the tangent is equal to 1. Therefore, the slope of the normal will be equal to -1. Okay. So now equation of the normal will be y minus 2 minus 1 x minus 1, which will be equal to x plus y is equal to 3. Right? Therefore, the point N has the coordinates as 0, 3. Okay. Now, we have to find out the area of the triangle TPN. Area of triangle TPN will be equal to half. Let's write down the coordinates. 0, 1, 1, 0, 3, 1, 0, it's 1, 2, 1, which is equal to, you have to find out the determinant, rest is that case. So 1 multiplied by, it is actually the modulus over here, 1 minus 3, which is equal to 1. Because 1 minus 3 will give you -2. The modulus will be 2. 1 divided by 2 into 2 is equal to 1. So we have option D as the correct answer. Hope you understood this question. Let's move to the next question then, 71. Consider two families of curves. Y square is equal to 4ax, where x is a parameter, and this where c is the parameter. If one curve from each family is chosen, then the angle between those two curves is. So first curve is y square is equal to 4ax, and the second one is x square plus y square upon 2 is equal to c square. Now let the point of intersection of these two curves be. Let the point of intersection of these two curves be x1, y1, right? So c1, which was equal to y square is equal to 4ax. Let's find out the first derivative of it. So 2y into dy upon dx is equal to 4a. Now add x is equal to 1, dy by dx at x1 will be given by 4a upon, sorry, this will be 2a because these will cancel out. So 2a upon y1. Okay, right? Now let the angle between these two curves be theta. Angle between these two curves be theta. So C2 will be given by x square plus y square upon 2 is equal to c square. Let's find out the first derivative. This will be 2x plus 2y upon 2 into dy by dx is equal to 0. Okay, so this will be dy by dx is equal to minus 2x upon y, right? So at x1, dy by dx at x1 is equal to minus 2x1 upon y1. Hope you got this. Now, tangent of theta will be given by dy by d1. See, I'll name this, wait, I'll give them different names. So I'll just give it number 1 and this one is 2. Okay. So dy by d1 minus dy by dx 2 whole divided by 1 plus dy by dx 1 dy by dx 2. This is equal to 2a upon y1 plus 2x1 upon y1. 1 minus this. This will be equal to 2a plus 2x, 2a plus 2x1 upon y1. This whole y1, I'll not touch this one. Okay, I'll leave it. 1 minus 4a x1 upon y1 square. Now 4a x1, this is actually equal to, yeah, this is actually, y square is equal to 4ax. So y1 square is equal to 4ax1. I'll fill in over here. I hope you're getting this, right? So you will have 2a plus 2x1 upon y1 whole divided by 1 minus y1 square upon y1. This will be equal to 2a plus 2x1 upon y1. Now this 2 will get cancelled and wait, over here it was y1 square. So both will get cancelled. Okay. Okay. So this will be 1 minus 1. That is, it is divided by 0. So, anything divided by 0, that gives you infinity. So that means tangent of theta is equal to infinity. So that means theta is pi by 2. Right. That is what we were looking for. We were looking for if one curve from each family is chosen, and the angle between those two curves is option D, pi by 2. Hope you got that. Next is question number 72. It says let a function fx be continuous in an interval ab. If delta is greater than 0, be a very small real number and c belongs to ab such that this whole expression and this expression for every delta greater than 0, let whole this expression is less than 0 for a all belonging to a comma b and a is not equal to c, then which of the following is true? Let's make this curve first. So there's a function, let a be the function, be continuous in this interval a b, and if delta is greater than 0, we have a very small real number. Let's make it. So if first thing c belongs to the interval a and b, and function c minus delta is less than f of c, and this is less than f of c. Yeah, sorry, less than. Okay, so using these things, I can make the curve. How? This is the curve. So this is equal to, this is the point FC. Here is FC minus delta, FC plus delta. Right? So here, FC is the point of local maxima. Right? Also, f of a minus delta minus f of a into this. This gives you f a minus delta minus f of a is less than 0, and f a plus delta should be greater than 0. Then only this is the whole multiplication of the two will be less than 0. Or this thing is greater than 0 and this thing is less than 0. Hope you got it. In either of the case, then only this will evaluate to be less than 0. That means no maxima and minima at A. So, therefore, no maxima and minima at A, where A belongs to A comma B. Okay. So that means fx has only one real maximum at C. Option C is the correct answer. Hope you understood this. Let's move to the next question. Question number 73. Let fx is equal to integral of, so this is an integral problem now. Integral of this whole function dx, and f of 1 is equal to 1. Then f of 5 is equal to what? The given function is integral of 2x cubed 3x square, this whole divided by x square into dx. So you can split it up. Fx can also be written as integral of 2x minus 3, 4 by x minus 5 by x square dx. Right? So I'm taking out the integrals now. So this will be 2 into x square upon 2 minus 3 into x plus 4 into log of x plus 5 upon x. Because, see, this will go in the numerator and the whole thing. I think you know like how to find out the derivative integral of 5 upon x square. So this will evaluate to be plus 5 upon x plus the constant c. Now you are given that f of 1 is equal to 1. So I'm filling f of 1. This will be 1 square minus 3 into 1 plus 4 into natural log of 1 plus 5 upon 1 plus c is equal to 1. So here, this will be 1 minus 3 plus 0, because log of 1, natural log 1 is equal to 0, plus 5 plus c is equal to 1, which will evaluate that c is equal to 1 minus 3, that is equal to minus 2. So c comes out to be minus 2. So fx was equal to x square minus 3x plus 4 log of x, this whole thing. So instead of c, I have filled minus 2 over here. So you had to find out f of 5, right? F of 5, this is what you had to find out. Yes. So f of 5 is equal to 5 square minus this plus 5 upon 5 minus 2. So this is 25 minus 15 plus 1 minus 2 plus 4 log of 5. This is 10 minus 1, that is 9, plus 4 log of 5. This is the answer to the question. Let's check. Option C is the correct answer. Hope you understood this. Next is question number 74. If x is greater than 0 and x is not equal to 2n plus 1 pi by 2, then integral of this whole expression is equal to what? So this question looks pretty difficult, but actually it's pretty easy. You're given x is great if x is greater than 0 and x is not equal to 2n plus 1 pi by 2. So then this whole integral, I'll just write down the integral of x root x minus e log secant x tangent x plus 3x squared minus 2x plus 1 upon x squared dx. So let's open it up. So you can get it as the integral of x raised to power 3 by 2, right? Minus secant x tangent x. See, this is log e, so this can be written as secant x into tangent x plus 3 minus 2 upon x plus this, right? So now let's find out the integral of everything. This is x raised to power 5 by 2 divided by 5 by 2 minus secant x. This is the integral of secant x tan x is secant x plus 3x minus 2 natural log x minus 1 by x plus c. So this can be written as 2 by 5 x square root x minus secant x plus 3x minus 2 natural log x minus 1 by x plus c. So this is equal to option D. Okay, so this is the correct answer to our problem. Hope you understood this. Let's move to the next question, students. But before moving, do visit our website, www.examsnet.com. There you will find a number of entrance exam question papers for not only this board, but other boards as well for your practice. The PDFs are also available, so that you can check out them and explore your learning. You can also download our app. The link is available in the description box. So hope you got that. Let's move to the question number 75. It says integral of 2x minus 3 root of into root 3x plus 2 dx is equal to what? All right, to answer the question, first of all, I'll put this 3x plus 2 is equal to t. Put 3x plus 2 is equal to t. So derivative will be 3 into dx is equal to dt. Now let's get back to our problem. Integral of 2x. So x can be written as, I'll write everything in the terms of t. X can be written as t minus 2 upon 3 minus 3 root of t into dt. Okay. Now, one thing, okay, a dx will be 1 by 3, so 1 by 3 will be taken outside, right? Now, this can be written as 1 by 9 upon integral of 2t minus 13 root of t into dt. So let's open it. 1 by 9 integral of 2 into t raised to power 13 by 2 minus 13 into t raised to power 1 by 2 dt. So let's open the intervals. You will have 1 by 9, 2 into t raised to power 5 by 2 divided by 5 by 2 minus 13 into t raised to power 3 by 2 upon 3 by 2 plus the constant, right? This will be 1 by 9 multiply 2 into 2 by 5 into t raised to power 5 by 2 minus 2 by 3. 13 was also there, right? So it can be written as 26 raised to power 3 by 2 plus c. I'll take the root 2 common now. So root t common. And yeah, this will be root t upon 9, 4 by 5 t square minus 26 by 3 into t plus the constant. Okay, now let's put back the t. The value of t was 1 by 9, 4 by 5, 3x plus 2 whole square minus 65, 3x plus 2 whole into root of 3x plus 2 plus the constant. Solving it further will give you 2 upon 135, 54x square. Like you will open up everything which is given in this line. 54x square minus 195x minus 106 root of 3x plus 2 plus c. So this is the answer to our question. Let's check with the options. This is option 8. Yeah, option D is the correct answer. Hope you understood this. With a slight modification, it was number 6. Okay. Rest, when you will open up this whole thing, you will eventually get with this. So this is the answer to our question. Let's move to the next one. Question number 76. It says integral of limits 1 to 4. This whole expression is equal minus log of integral of 1 to 2 log 2 dx is equal to what? So you are given basically, let's write down integral limits are 1 to 4, x plus root of x plus 1 by x dx minus integral 1 to 2 log 2 dx is equal to what? So let's open it. You will have x integral is given by x square by 2 plus 2 by 3 into x raised to power 3 by 2 plus log of x limits 1 to 4 minus x 1 to 2 log 2. Okay. So now let's fill. You will have this x square by 2. So this is 4 square by 2 plus 2 by 3 into 4 raised to power 3 by 2 plus log of 4 minus 1 by 2 plus 2 by 3. And log of 1 will be equal to 0. So I'm not writing that. Minus 2 log 2 plus 1. Right? Okay, I hope you got this. So next is, this is 4 into 2, which will be 8 plus 2 by 3 into, this will be 2 raised to power 3. That is given by 8 plus log of 4 minus 1 by 2 plus 2 by 3 minus. So log of 4 actually this can be written as log of 4 as well, plus 1. These two will cancel out. Okay. Next is 8 plus 16 upon 3 minus 1 by 2 plus 2 by 3 plus 1. This on solution. Let's take the LCM. You will have 6 over here and 48, 32 plus, and then you have minus 12 and 2, 4 and 6. So this will eventually give you 79 by 6. This is the answer to the question. That means we have option A as the answer. Hope you got that. Let's move to the next question then. Question number 76. You are given the integral of this function minus integral of dx. The limits are given to you. So basically you are given two integrals and you have to find out the solution for the problem. Okay, let's start with that. So basically it's very easy question, not at all if there is anything tough. So this whole, I'm directly going to find out the integrals now. X integral is given by x squared by 2 and root of x integral is given by x raised to power 3 by 2 divided by 3 by 2. 1 by x integral is given by natural log of or log of x simply. The limits are 1 to 4 minus integral of 1 dx. This is actually equal to 1 into dx. So here is x limits are 1 to 2 log 2. Okay. So x square. Now let's put in the limits. X square. This is 4 square upon 2 plus 4 raised to power 3 by 2 multiply 2 by 3 plus log of 4 minus 1 by 2 minus 1 multiply 2 by 3 minus log of 1. Actually, this is equal to 0 only. Minus now 2 log 2 minus 1. Okay. So this will say 4 into 4, like 16 divided by 2. This is 8. 4 root is 2. 2 raised to power 3 gives you 8 again. But this is 16 by 3. Okay. 16 by 3 log of 4 minus 1 by 2 minus 2 by 3 minus 0 minus 2 log 2 can be written as log 4 only. Actually, this is natural log. So same ones. Okay. Then plus 1. These two will cancel out. And let's find out the LCM. I'll be left with 8 plus 16 by 3 minus this minus 2 by 3 plus 1. LCM is 16, 48, 32, 3, 4, and 1. So this is equal to 81 minus 7. Right. 81 minus 7 upon 6, which is equal to 74 by 6. Actually, I made a mistake. Here was supposed to be 6, and this will be 80. So this is 86, right? And this has got to be 79. Okay, so the answer is 79 upon 6. Let's check. We have option A as the correct answer. Hope you got that. Next is question number 77. Again, an integral problem with us. Looks tough, but it's okay. So let's start with it. It says, let I be this integral, given that integral of dx upon 1 plus kx square is equal to 1 upon root of k, tan inverse root of kx plus c, tan inverse of 0 is equal to 0, and tan inverse of root 3 is equal to pi by 3. Then 3i square is equal to what? Now, first of all, you are given this particular integral. Okay, I'll remove this thing. I'll just try to solve the inner part, inner expression first. So I'm saying let fx is equal to 1 upon 2 minus cos 2x 3 upon pi plus log 4 plus sin x 4 minus sin x dx. Not dx actually. I'm just taking it as such. Okay. So this is fx. Now f of minus x. This can be written as 1 upon 2 minus. So cos of minus 2x, this is actually equal to cos of x only. So this will not alter. This will be cos 2x only. 3 pi plus log 4 minus sin x 4 plus sin x. Okay. Solving it further. This is equal to 1 upon 2 minus cos 2x 3 upon pi minus sine, like See, I'm flipping them and this plus will change into minus. Okay. Which means f of x plus f of minus x is equal to, I'll add both of them and I'll get, this will be 6 upon pi 2 minus cos 2x. Okay. Now let's get back to our integral. So integral was I is equal to limits minus pi by 4 to pi by 4 fx dx. So if I'm changing the intervals like 0 to pi by 4, this can be written as fx plus f of minus x dx. This is equal to 6 upon pi integral 0 to pi by 4 1 upon 2 minus cos 2x dx. So integral is given by 6 upon pi 0 to pi by 4 1 upon 2 minus cos 2x can be written as 1 minus tan square x 1 plus tan square x dx. This is equal to 6 by pi integral 0 to pi by 4 1 plus tan square x upon 1 plus 3 tan square x into dx, which will say 6 by pi integral 0 to pi by 4 1 plus tan square, this is equal to secant square tan square x dx. Okay, now I'll put tan x is equal to t. Put tan x is equal to t. So if tan x is equal to t, then what is it's a derivative. Let's find out derivative. Secant square x dx is equal to dt. So this whole thing will now become 6 by pi integral. Also the limits will change. Okay, for 0 limits will change to 0 to 1. Okay, when tan pi by 4 is equal to 1, so t is equal to 1 at pi by 4. Hope you got this. So this is equal to dt upon 1 plus root 3 into t square. Okay. So this is equal to 6 upon pi into 1 by root 3 into tan inverse root 3 t. Limits from 0 to 1. So this is 2 root 3 upon pi tan inverse. So when t is equal to 1, this will be tan inverse root 3 minus 0. This is 2 by root 3 pi. So when is tan inverse, what is tan inverse of root 3? This is equal to pi by 3 minus 0. This will cancel out and this will cancel at this. So you have 2 upon root 3, right? But in the question, we were supposed to do 3i square is equal to, we got I, this was your I, 3i square will be equal to 3 into 2 upon this into 2 upon this, that will be equal to 4 because these will cancel out. Okay, so you have option A as the answer. Hope you got this. Let's move to the next question, number 78. It says the differential equation of the family of circles with the fixed radius r units and the center on the line y is equal to 3. So y is equal to 3 line. This is the coordinate axis. Then y is equal to 3 line is this. So its center is lying on this line. Okay, the family of the circle with the radius, fixed radius r units. So this radius is supposed to be r units. And this point, like x can have any value, x1, but y is got to be 3 only. Okay, So the general equation in this case will be given by x minus x1 square plus y minus 3 square is equal to r square. Now on differentiating both sides, you will get 2x minus x1 plus 2y minus 3 into y is equal to 0. X minus x1 will be equal to, this will go on this side. So actually 2 will get cancelled. So I'm not writing down 2 now. Y into y minus 3. That's it. Because 2 will get cancelled, okay, on either side. Now, on putting this one in equation 1, this if I'm taking as equation 1, so let's put this in equation 1. You will have y minus 3 squared into y squared plus y minus 3 square is equal to r square, which is 1 plus dy by dx square is equal to r square upon y minus 3 square. Okay. The differential equation of the family of circles with the radius r units and center on the line y is equal to 3 is. So let's make the graph to understand this. This is the x and the y axis. So this is the line y is equal to 3. So the center lies on this line, the differential equation of family of circles. So this is the family of the circles, which is having the fixed radius of r units and the center will lie on this line only. So let this be the circle. Okay. This is the radius r. This is the radius r over here. And for such type of circles, the general equation will be given by x minus x1 square plus y minus 3 square is equal to r square. Now on differentiating both the sides. Both sides you will have 2 into x minus x1 plus 2 into y minus 3 into y dash is equal to 0. I'll cancel 2 on both the sides. So you will have y dash as, okay, not y dash. You will have x minus x1 as minus y dash into y minus 3, right? Now let's put this one in equation first. You will get y minus 3 square into y dash square plus y minus, just let me see once. Okay. Okay. Plus y minus 3 square is equal to r square. I'll take y minus 3 square common from here. Y minus 3 square is common. So you will have 1 plus y dash, which is the first derivative actually, is equal to r square. So 1 plus, this is dy by dx only, the first derivative, square is equal to r square upon y minus 3 whole square. So let's check which is the correct answer. Option A is the correct one. Hope you understood this. Next is question number 79. The degree of the differential equation, this is the differential equation given to you. You have to find out the degree of it. Okay, let's write it down. X into d square, like the second derivative of y with respect to x raised to power 1 by 3 plus 2x square d square y dx square raised to power 5 by 3 plus 7 dy by dx plus y is equal to 0. So this can be written as x into d square upon dx raised to power 1 by 3 2x square raised to power 5 by 3 is equal to minus 7 dy by dx minus y. See, now I am having the powers 1 by 3. So cubing both sides to make them perfect ones. Cubing both sides, you will have x into d square y upon dx square 1 by 3 plus 2x square d square y upon dx square 5 by 3 whole cube is equal to minus 7 dy by dx minus y cube. So when you will solve this, see, this will be 5 by 3 multiplied by 3. This will give you the power of 5. So that means the degree of this differential equation is got to be 5. Right? That means we have option B as the correct answer. Hope you understood this. We don't need to go for the calculations like what the answer will be. We are just worried about the degree of this differential equation. So the highest degree will be 5 only. With that, we have come to the last question of this paper, question number 80. Let's go with this. The curve that satisfies the differential equation xy dy minus 1 plus y squared dx is equal to 0 passes through 1, 0 and intersects the curve x squared plus 3y squared is equal to 3 at an angle theta. Then 2 theta upon pi is equal to what? All right. So first thing, let's write down, you are given that x y dy minus 1 plus y square dx is equal to 0. Integral of y upon 1 plus y square into dy is equal to integral of dx upon x. Like how did you get on this was? xy dy was equal to 1 plus y into y square into dx. So I'm taking this y upon 1 plus y square. I'm taking all the y terms on the LHS and all the x terms on RHS. So taking now, after this, taking integral on both the sides. Right? Now y upon 1 plus y square, this is the integral half log of 1 plus y square. This is equal to natural log x plus c. Now this passes through the point 1, 0. So this passes through the point 1, 0, which means half natural log. So this will be 1 is equal to this plus c, which will, this is equal to 0 and this is equal to 0, which simply means that c is also equal to 0. Now this means half log of 1 plus y square is equal to log of x, which means log of root of 1 plus y square is equal to this, which simply means x is equal to root of 1 plus y square. So for the first one, for the first curve S1, I'll have 1 plus y square is equal to x square. This is number 1. And for S2, x square plus 3y square will be equal to 2. This is number 2, right? So look at this one. All right. Next, y will be equal to plus minus 1 by root 2. Now, how is this? See, solving these both equations, you will have 1 plus y square is equal to 3 minus 3y square, which will give you 4y square is equal to 2, or y square is equal to 1 by root 2 plus minus. Okay. So correspondingly, you will have x square is equal to 1 plus 1 by 2, which will be equal to 3 by 2. Okay, so ultimately, what will be the value of x? This will be plus minus root 3 by 2. And we got the value of x and y. Now, for the first curve, S1, we have y square is equal to x square minus 1. Let's find out the derivative of it. So 2y into y dash is equal to 2x. Now, at x is equal to 1, this derivative y dash at 1, like not x is equal to 1, sorry, the first one, this will be, these two will get cancelled and this will be x upon y. So x1, this is equal to x1 upon y1. For the second curve, S2, we had the equation as x square plus 3y square is equal to 3. Now let's find out the derivative. This is 2x plus 6y into y dash is equal to 0, which gives you y dash at x is equal to 2. Not x is equal to 2. For the second one, the second case, it will be equal to, you will be like solving this and you will get minus x1 upon 3y1. Now, let's find out the angle between them. That will be given by tangent of theta is equal to y1 dash minus y2 dash upon 1 plus y1 dash into y2 dash. So this is given by, this is actually equal to x1 upon y1 plus x1 upon 3y1 upon 1 minus x1 y1 multiplied by x1 3y1. So this is equal to 3x1y1 plus x1y1 upon 3y1 square whole 1 minus x1 square upon 3y1 square. Okay, ultimately you will solve this. So then you will get it as 4x1y1 upon 3y1 square minus x1 square. Hope you got till here. Now, what was the value of x? We calculated it was equal to root of 3 by 2 and y1 was 1 by root 2. So let's fill in over here. You will get it as this is equal to 4 into root 3 upon 2 multiplied by this upon 3 into 1 by root 2 into 1 by root 2 minus x was root 3 by 2 whole square. Whole is having the mod, right? So next it will be, let's do the calculations. This will cancel 2, 2. So this will be 2 root 3 upon root 2 whole divided by 3 by 2 minus 3 by 2, which actually is equal to root 6 upon infinity. Wait. This was under the whole root. So this will also get cancelled and this is equal to 2 root 3. Okay. So this is tangent theta, not infinity, sorry, 0 over here. So tangent of theta is equal to 2 root 3 upon 0. That means tangent of theta is equal to infinity, which is only possible when theta is equal to pi by 2. All right. So let's see what we had to find out. 2 theta upon pi. This is what we had to find out. So 2 theta upon pi. Theta we calculated as pi by 2 upon pi. This will get cancelled and you will have 1. That means we have option D as the answer to the question. Hope you understood this. So students, with this, we have completed all the 80 questions for this paper, actually mathematics questions for this paper. Hope you understood this well and you are well prepared for your exams. So keep shining high, keep rising high. Best of luck for your exams. That's all for this paper. But before leaving, students, do visit our website, www.examsnet.com. There you will find not only this, but a number of other entrance exam question papers. Our app is also available. The link is given in the description box. So do explore our website and do download our app to explore more. A very best of luck for your exams. That's all for this paper. Bye.